Good afternoon, everyone. I'm delighted to welcome you all to today at the OECD to discuss the hidden costs of AI. My name is Karine Perset, and I'm acting head of the AI and Emerging Digital Technology divisions. And a big thank you to IEEE for suggesting that we collaboratively organize this event in order to convene experts and stakeholders to discuss this crucial topic today. For those of you who don't know the OECD, we are an intergovernmental organization of 38 member countries that cover all policy areas from tax to climate to artificial intelligence, all topics except for defense and anything military related. We're very well known for the OECD AI principles that were adopted in 2019 and later revised in May this year, last year, May 2024, to keep pace with technological change. The core of our work focuses on creating an evidence-based resources and tools to help policymakers translate fundamental AI principles into practice. We've been working on AI in the environment since 2021. And have created, at that point, we created an expert group on AI, compute, and climate that's been meeting since then to assess and understand AI compute capacity internationally. And now moving forward with increasing interest from policymakers on the environmental impacts of large AI models, and not just policymakers, but society at large. We released a report in 2022 on the environmental footprint of AI in partnership with the Global Partnership on AI Experts. And that report highlighted the importance, but also the limitations of measuring the environmental impact of AI. Policymakers indeed lack clear and standardized indicators and benchmarks to guide sustainability decisions for public and private sector investment in AI. The development of a technical standard to measure the environmental impact of AI, done in partnership with IEEE, is a natural continuity of the findings of that report. So the event of today will actually feed into the discussion of the IEEE P7100 working group that was launched in September 2024 to develop this technical standard. We really love IEEE IEEE acronyms. So today our speakers will explore often overlooked aspects of AI's sustainability challenge, the environmental impact cost of inferencing, the impact of data centers on the electricity grid, and AI water usage. I thank our speakers for being here today to share their expertise with us. Starting with inferencing, this now accounts for a significant share of AI's environmental footprint. Until now, the discussion around AI's energy consumption was largely focused on the training of AI models as opposed to actually using them, so the inferencing component. But before the inferencing, so the actual use of the models, AI's growing reliance on data centers is placing immense pressure on electricity grids. Data centers globally consume more electricity than some OECD countries, and this we expect to increase over time. And AI's environmental footprint isn't only about energy, but also about water. AI models require extensive cooling, leading to large amounts of water consumption, and often in regions that are already facing water scarcity. So our speakers will set the stage for you to discuss these sustainability challenges and examine ways to mitigate their impacts. Ensuring AI development aligns with sustainability goals will require multi-stakeholder collaboration across governments, industry, and standard-setting bodies like the IEEE. The OECD is really delighted to foster with IEEE such a dialogue today. I really look forward to this afternoon's discussions and the insights they will bring, and will now pass it over to Clara Neppel, who is Senior Director of IEEE European Business Operations. Clara.
Thank you very much, Karine, and thank you for having us here. So my name is Clara Neppel. I'm the head of IEEE Europe, but I'm also part of several OECD expert groups, and one of them is on AI and climate. So we also very much welcome this collaboration. So those of you that don't know IEEE, just a little bit on IEEE. We are celebrating this year 140 years anniversary. We were founded at that time, among others, by Edison. Also with a nascent and new technology at that time, which had a potential, but also had some impacts and safety issues. And I think that we are in a very similar situation right now. So the last 2 days showed us very clearly the potential of artificial intelligence and all the revolutionary things that we can do with this technology. We also know, as Karine also mentioned, that it has impact on the environment and also on society. So the question is really, and I think that we all agree, we want to make sure that this technology has a net positive impact, that the impact that we have from this technology, the positive impact is bigger than the negative one. But in order to do this, we have to assess what are these positive and the negative impacts. And we hear a lot on some of the measures that are out there. Some of them are not verified. So as Karine said, we need measures. We need, first of all, to agree what do we measure, and then how to measure these different dimensions. And as already mentioned, it's not only about energy, it's not only about greenhouse gases, it's also about other dimensions as water, as inference cost, and so on. And standardization is about creating a common language, about creating a common terminology first. So it's maybe the first and foremost aim of standardization. It has, of course, also other aims: interoperability, safety, security, and so on. So we're very happy that we are working together on this, and that we established this working group. What I wanted also to mention to you that the IEEE working groups are open, so each of you can join the working group. It's without cost. All we want is your time and your expertise, and we invite you to join and hopefully establish this standard, which I'm sure is going to be then adopted, because it is important to organizations, industry, as well as to governments to assess these dimensions. So with this, I'm also looking forward to the discussions, and I would like to hand over to Noman from MIT, who is online.
Hi, everyone. I hope you can hear me. I'm Noman Bashir. I am Computing and Climate Impact Fellow at MIT, and I am a part of MIT Climate and Sustainability Consortium, as well as Computer Science and AI Lab. My work focuses on understanding and optimizing the carbon footprint of computing. And I think we have a very nice set of talks, panels for the next couple of hours. And I wanted to just point out a few things that are important to consider as we talk about different aspects, how the interaction with the grid must be, what is the impact of inference, and what are the environmental impacts beyond just carbon footprint. So I feel that the most important thing right now is to understand what the current incentives are in computing landscape to reduce or optimize the use of AI or the resources that it uses, which I feel that there are not adequate uh, incentives right now. So we need to understand, because like companies make like thousands of dollars based on the energy they use to like power training and inferences. It's very hard to provide any kind of financial incentives to them that would make them change their behavior. So in such a scenario, like policy and regulations would need to come into play to make sure that the right decisions are being made. And then in making those decisions, it is very important to have a like common set of agreed upon like metrics that are quantifying the underlying phenomena. But as these, like for example, in AI supply chain hardware and its embodied carbon emissions like happen in a very complex supply chain, the data can be often very unreliable and has a lot of uncertainty in it. So in those cases, just looking at a single number would not give you a complete picture, and the goal should be to understand the uncertainty and how it impacts our decision making. So that should be kept in mind. And the third thing is that so far we have had this notion of reliable and unlimited power supply from the grid to data centers. And that notion is breaking in a lot of regions. And what we need to do is that since computing workloads has a lot of flexibility and they can respond to variations in the grid, and they can actually be an asset for the grid rather than being a burden, which currently they are. And that is also creating issues around environmental justice and electricity access. For example, the rates near the data centers or where the power supply for the data center is coming from, the rates for normal consumers go up because data centers do not pay for the upgrades of the electric grid. At least that is the case for United States. And then finally, what we need to consider is that carbon footprint is a very like easy metric, and people have been talking about it, but environmental impacts go beyond carbon, such as water usage. And also, as we saw in the pandemic, when computing companies could afford very um, large number of GPUs, academic institutions had very hard time procuring GPUs for academic research. So that is also an impact, maybe not environmental, but an impact that um, like basically influences our ability on how we can make academic progresses without any kind of like purely profit in mind. So there are a lot of impacts of computing and AI and its growth that go beyond carbon, and we should keep those in mind as well. And with that, I would hand over for the next panel.
Can you hear me? Can I ask everyone who's sitting in the back rows, please move to the tables. We just put some name tags out in order to sort of facilitate people sitting at the tables, but we want to have an open discussion here. And so I'll ask you to move up. You probably do have a name tag printed if you want to look for it, but otherwise you can just introduce yourself if you ask questions.
Thank you, Arti. Shall we get going with the first round? So my name is Nicolas Miaille. I'm the CEO of Prism Eval. We're a small startup based here in Paris that does testing of frontier AI models and systems. I also have the pleasure of serving as one of the global partnership on AI experts, co-leading the project RAISE, which stands for Responsibility Strategy for the Environment. And back in 2022, as Karine mentioned before, we worked with the OECD to start in a way scoping what could be an analytical benchmark and for measuring the environmental footprint of AI compute, starting with the energy and the water consumption. So today's initial roundtable session, and we're going to kick it off with a little panel conversation. And I'm surrounded by fantastic experts and practitioners, and look forward to hearing from you on that. And then we'll open up for a moderated conversation. We have, if I'm not mistaken, up until 2:40, all in all, giving us time, but at the same time, not so much time. So I would ask everyone to keep their remarks to the point and as short as possible. But obviously, comments are welcome, not only questions. It's a roundtable, so I look forward to your comments. And maybe before we kick it off with the panel, I want to anchor a bit the conversation as to what we're here to talk about. Starting, as we've discussed, with trying to understand the environment cost of inference. I think to begin, it becomes important to anchor a bit the conversation in terms of what we mean by inference. A lot of people understand quite well what training is, at the same time, not so much what inference is. So to set I would say not the record, but set the conversation in the right direction, it's really the phase where pre-trained models are deployed in production and respond to queries and requests at the application layer. So it's really something that scales very well and very much with demand. So that's really the kind of cost besides pre-training that we should pay a lot of attention to. And the recent tit-for-tat response within experts and even within the stock market between OpenAI and DeepSeek over the cost, both of pre-training, but I think more importantly of inference of R1 DeepSeek, V3 DeepSeek that we've not necessarily discussed that much besides R1, and the competing models from OpenAI. That conversation is very interesting to carry forward. So really inference continuously scale. It's driven by demand. It's not a one-shot like training is. And yes, there are overlapping concepts. You are going to hear a lot more over the next years over new architectures that enable, or not so new architectures, but newly rediscovered architectures that enable continuous pre-training. But let's say it's different. Inference really begins at the point of production when a model is deployed in production. And if inference represents what we call the real-world deployment of AI, it's really what we should, I think, focus on. That's why we're starting that conversation this afternoon with that topic. When we say that we want to be optimizing the cost of inference, I think it's also important there to try and round a little bit what we mean by optimizing. Yes, when we want to model, to optimize AI inference efficiency, there is a part of this which has to be done at the model level. And you would have heard about techniques to optimize the model inference cost. That's something that DeepSeek has explored quite a lot, but everyone is doing it. Quantization, for example, which is the idea of reducing the number of computes under which the inference happens from 32 to 8 integers. I think it's something that is used a lot that may impact performance as well. And we, for example, at Prism Eval, when we test and evaluate models, not on the environment footprint, but on the risk of prompt injection, we pay, so the robustness, basically, we pay a lot of attention to the quantization and which model are we testing, because versions differ, and it's important to create a level playing field. And to sparse also this model, which is to try and go back into these big matrices and clean up the artificial neurons and remove the parameters that are really not used in compute. So that's at the model level. But there's a lot happening, and that should happen beyond the model level at the system level. So of course, not all models are equal in terms of cost of inference. And so, one of the concepts that you will and that we need to discuss more over the next hour and beyond is this notion of computational overkill. Not all use cases are equal in terms of the kind of intelligence that we need to mobilize. And in some cases, small large models are sufficient to carry forward the day. So we also need to think about optimization at the system level. Never, very rarely, at the application layer is the model deployed alone. Usually, it's equipped with a number of software scaffolded elements that includes guardrails, that includes database to the retrieved augmented generation, and in increasingly agentic pipelines and loops that other softwares to call on other functions and other databases, for example, our mailbox, a map, or so other software elements. And when we look at system optimization of AI over the cost of inference, I think it's important to look at this system-wide approach. Obviously, there is all the part on hardware efficiency. How energy efficient are the chips? We're talking a lot, and there is a relationship with the quantization, which is the idea of trying to run these models at the periphery, not on the cloud, on our laptops, on our phones, meaning what we call at the edge. But there is also the notion of trying to run these models not on GPUs, but on CPUs, really trying to be able to use existing hardware, which is much more energy efficient to run these systems. And obviously, there's a huge kind of a set of trade-offs that we need to be able to discuss between overall performance and sustainability when we look at the cost of inference. Because what people in the trenches developing and deploying applications, what they do and what they need to optimize, when they need to balance out more, because it's really a trade-off, is obviously the cost, but also the need to be accurate, and accuracy as a price, the need to minimize the latency. If you had to wait for your preferred chatbot to respond to you for over 2 minutes, well, you're going to quit the application. So latency is a very big problem. And these things come into play. So I think that we can summarize the concept of true optimization as the idea of choosing the right model, the right infrastructure, and the right deployment strategy for each use case. And before we get into the little panel, I want to introduce a concept which I think has been in the news and an underlying preoccupation over the past few weeks with the DeepSeek so-called revolution, is what we call the so-called Jevons paradox. So what is Jevons paradox? It's initially an historical observation that has been captured in our imagination over the relationship with the optimization of our steam engine, what operates, and the consumption of coal. So contrary to what we would intuitively believe, the efficiency gains do not necessarily translate in a reduction of consumption. Actually, they can be passed on to increase consumption. And that's a paradoxical element that is now hitting AI, because as we tend to use, to be able to reduce the cost of inference, the likelihood is that we are going to use and deploy AI even more. So this idea of computational overkill is going to be, I think, central. I now want to initiate our little panel conversation, and maybe I can start with you, Thierry, if you look. Don't forget to press the button after I've handed over my question, and you will be able to have your voice amplified. So you are a software engineer at CO2 AI. And CO2 AI, as I understand, is a platform that really tries to automate the way in which companies' carbon footprint can be assessed. So based on your experience, can you tell us a little bit more as to what you see as the so-called hidden cost of inference and how to measure it across the industry?
Thank you so much, Nicolas. I'm super glad to be here. So yes, my name is Thierry Dance. I'm responsible for AI development at CO2 AI. Very quickly, CO2 AI is a spin-off from the BCG. We are a SaaS platform dedicated at helping very large corporations compute their carbon emission and decarbonize. We are not only about computing, we are also about giving the companies a roadmap. So I would like to address the idea of hidden cost of inference in two different points. First of all, I would like to talk about ourselves, the work that we have done internally in optimizing our own costs, because we are not only an AI company, we are a sustainability company, and there was no way that we would come up with a system that was way too reliant and emissive in terms of carbon. And a lot will be said on system level optimization, Nicolas, because this is really what was at the heart of our work. And secondly, I would like to generalize a little bit and talk about how we measure emissions related to inference across the industries that we are monitoring with our clients. So first of all, we are, as I said, a sustainability and an AI company. Our mission is to help the world reduce carbon emissions by 500 megatons per year, which is quite an ambition. But so there is no way that in the system that we are designing to help those companies compute their emission, every time they press on the button, compute my footprint, if their footprint augments by 0.1%, this is not going to work. So we had to come up with a much cleverer way of doing it. And so much can be said in constraints in life, and we have seen it with DeepSeek. They did not have access to the same kind of hardware as maybe other American companies, and those constraints, maybe also less money to put on the topic, had them to drive and come up with super impressive innovations. And as a startup, we have had exactly the same journey. I'm sure that if I had millions of dollars to spend on the problem of computation of carbon footprint, I would have come up with a very different solution, and one that might have been much more emissive in terms of carbon. So the system that we came up with is not only scalable, but it gives full autonomy to the clients. They can recompute the footprint once every 3 months if they want, 3 times a day if they want. It has almost no impact in terms of CO2 emissions because we have optimized the process so much. And of course, as you were mentioning, there's also latency. The smallest inference we are actually asking from the system, the quickest the whole computation takes place. So very quickly, what does it mean to measure emissions using AI? I won't get into details, but our clients, they come up with very large inventories of millions of activities. And for each of those activities, we are pairing them one by one with what we call an emission factor that allows us to go from, I don't know, kilometers of airplane flight for a passenger to kilogram of CO2 equivalent, tons of steel to kilogram of CO2 equivalent, kilograms of apples, kilowatt hours, all those activities. We are trying to come up with a way to measure their emissions. This is done by using emission factors, and the pairing, the association, is where our AI system was designed and optimized. So let's maybe start by understanding that certainly there is a cost of inference. There is also a cost of not using AI. When I arrived in the company 2.5 years ago, we were still very much with a BCG DNA running in our veins. And when we had to compute one footprint, it would generally take 4 BCG consultants working BCG hours for a month and a half. And this also has a cost. Now the same footprint gets computed entirely with AI in less than 2 hours. I promise you that if you compare apple for apple, the general emissions of our system is much lower than the ones that used to do before. So very quickly, without details, we had the choice of fine-tuning models. We decided not to go there. We're so happy not to do it. We have implemented a very custom implementation of retrieval augmented generation system. We vectorize our activities, we vectorize our EFs. This allows us to get to a short list of possible choices, and we only use LLM in very short context windows to help to choose the finest emission factor possible. This allows us to have a very small number of tokens in input, to have a very small number of tokens in output, and we can use not super sophisticated models because the question is so easy that an 8-year-old would be able to get it right at least 90% of the time. So this is us. Now, how can we generalize things across the industry? So first of all, our clients, they are mostly in the industrial business, so they do not see right now a very significant part of the footprint being LLM inference. But we are very confident that this will dramatically grow in the years to come. So we will have eventually to come up with heuristics to evaluate those emissions. So we have basically 3 different kinds of approaches: spend-based, activity-based, and a full LCA analysis. So there are, I will quickly go through them very quickly. Spend-based is where we only take basically the cost of an inference process to estimate the emissions. This is as good a system as we currently have. We would love to have more and more accurate measurements, but this is, for example, the methodology that was used by a wonderful post by Boris Gamazaychikov to raise awareness on the cost of inference linked to one task of a reasoning model. So one inference measured 700 kilograms of CO2. Just it was running for maybe 1 hour, and it cost $3,000 and something, and it implied 1.7 kilowatt hours of energy. It's a huge impact. We have to be aware of that. The only way Boris was able to measure this was through cost. And he had to infer emissions through cost. Secondly, we would love to have activity-based emission factors. In our industry, they are the gold standard. This is really where we love to have things coming from, but we don't even know what would be a correct unit. Would it be one task? Would it be a GPU, the hours of GPUs? How even would we come up with an appreciation of how we can estimate a task and its associated emissions for example, a reasoning LLM. Thirdly, and I will finish with that, the life cycle analysis is even better than that, because you really take into account the full hierarchy of all the energy that needed to be spent in order to come up with the model. So this, of course, in a full-scale LCA implies that we take into account the training of the model and that we find a way to depreciate the cost of training into each inference. We have also to take that into account for a full LCA analysis. This is something that should be made. Also, this implies to take into account what we call scope 2, so the energy that is spent for inference, so electricity. Cooling, you were mentioning it, which implies to switch from a purely carbon approach to water consumption. But also, let's not forget the energy that was spent and the resources that were necessary to create the chips. And finally, what we call end of life, which is basically disposal, recycling. This is entirely taken into account by the GHG protocol, which is the framework under which we measure the emissions. So right now, to summarize, the industry is a bit lagging behind in terms of the resources that we are able to mobilize. We have every expectation that there will be a dramatic increase in terms of usage of inference. We absolutely need to measure as precisely as possible those emissions. We do not currently have the tools to do that as precisely as we could. If we don't have precise measure, we cannot decarbonize as precisely as we want. So this is a major impact for us. We believe that there is a lot to be said about standardization. Where do we put the boundaries of emission? That the emissions start at training? Do they not? In effect, in a certain way, I don't even care. What I want is to have a generalized framework that everybody agrees upon, and we measure the same way everything. Finally, advocacy. Just as a quick anecdote, one of the finest developers in our company, I had to teach him for 10 minutes yesterday the difference between a GPT-4o and o1. The concept of a reasoning model was not clear to him, and the implication in terms of inference costs are huge. So let's all realize that we have a role to play in explaining that the new models that are coming up, the new kids in town that are being so much talked about, they have huge implications in terms of inference, and let's make sure that we are not using them where it's not necessary. That's all I can say for now.
Thanks a lot, Thierry. I think you covered a lot of ground. I'll pick one of the points, like my good friend Elam Tabasi at NIST would say, if you cannot measure it, you surely can't improve it. I think it's a motto for anyone interested in metrology. I want to switch to Theo Alves da Costa. You head the AI for sustainability at Equimetrics here in Paris. And you have been developing solutions to help companies accelerate their ESG reporting. It's been something quite trendy and useful to accelerate the ecological transition. And as you see companies, slowly adopting these tools, can you share a bit more of your experience in terms of how practically AI and data can help us and companies estimate the cost of AI inference better and more?
Sure. Hello, everyone. So I'm an AI engineer at Equimetrics. I'm developing climate and sustainability solutions, but I'm also a president of an NGO called Data for Good. So I have also examples that I can draw from the conversation, from things I've seen also elsewhere. What we do mostly right now is like accelerating reporting, because that's what companies need in the sustainability field. Carbon accounting is also one of the key areas as well, and there are other topics. So I will talk about what I'm seeing with inferences right now in like many industries. One of the big questions that I see is the question of scale and the question of complexity. Inference cost, whether it's money or carbon or water or whatever, the first question is scale, and scale can come from a lot of things in industries. Scale can come from, in reporting, for example, is the number of questions that we are able to fill with AI. So let's say, for example, the CSRD, it's 1,200 questions. So if I'm running an inference on CSRD, I'm running it for 1,000 times. If I'm doing it twice because that doesn't work, or I need to reiterate, very fast, I will have tens of, or 15 or like maybe hundreds of thousands of inferences. So scales can come from that. Another example is we have built 2 years ago a really useful tool that a lot of scientists have been using, that called Climate Q&A. It is called the IPCC ChatGPT. Basically, we made it, the IPCC available through a chatbot, and it's been used by a lot of scientists, a lot of journalists worldwide. And scale comes from another thing. Scale comes from the fact that a lot of people have been using it, for example. I will say a third example, not in the sustainability field, but I've been working a lot with companies doing, for example, product review, product sentiment analysis. And scale in that case comes from the number of products that you have on your website. If you want a generative AI system to assess the sentiment of a review of a product, you can have tens of reviews for a product, and you can have thousands of products. So that question of scale is really important, because that comes from a lot of different possibilities in companies and organizations. So if you have something that maybe consume a little bit of energy, but you scale it by 1,000 times, like hundreds of thousands times, or millions of times, the question is absolutely different. Sasha Luciani, like one of the most famous researcher in that area, estimate that the cost of inference starts to outweigh the training above from 50 million usage, and 50 million can come super fast or super slow depending on the use case. 50 million is maybe in 2 hours of ChatGPT, and it can be never for the things that we build, for example, in organizations or companies. So that really depends on, first, the scale. The second question is on the complexity. Complexity can also come from on a lot of different topics. Complexity can be like a super small language model, or just like a really typical classical AI system. But complexity can be a reasoning model that we explained just before, like O1 or DeepSeek R1 and stuff like this. And this actually comes really fast, because with complexity, most of the time comes also performance. Let me give you an example on ESG reporting. I have had a client that said to me, I've seen that O1 from OpenAI was released. Can you do the CSRD on O1 and not on GPT-4o? And then that means that the incremental of inference cost that now is being scaled on the number of usage can become really big. And if we use estimates, because that's one of the only things that we have with OpenAI. No, that's the only thing that we have with OpenAI. We saw that we could, if we agreed upon that demand from the industry, we would go from like a system that would consume basically nothing, even with the scale, from a system that was actually visible in our own carbon footprint. So then there is the question of measurement. I think we'll come a lot on that. So how do we know those kinds of stuff? Basically, we have 3 ways of measuring, estimating this when we build those kinds of systems. We have the hardware things that we actually handle. So we know from different cloud providers that we use the energy consumption of the services that we use. So we have proper figures, kind of estimates that help us get at least a global view also on the storage, not only on the compute, so on the whole AI system that we build. We also have some proper measurement with tools like Code Carbon that we actually incubate at my NGO. That is a tool used a lot by developers to actually measure the carbon emissions and the energy consumption of different various CPUs, GPUs, RAMs, and other architectural settings. So we use that when we actually master our own server and we do the AI on our own. And then there are the APIs, so that the external provider services that we use. So for example, when we are asked or we want to use OpenAI or Mistral or any provider that computes something on their own. And then it's when comes the big problem is that we don't have those figures. So that's why there has been a lot of discussion in the AI Action Summit to actually get those figures, because we need that. So we use estimates. So for example, at Techimetrics, we use a tool called Ecologits that basically do extrapolations from similar model. And so that means that any data point can become useful to actually extrapolate from a similar model. Boris, that is in the room and has been already cited, has launched yesterday something called the AI Energy Score, so that we can actually standardize that and get a few more data points that we can actually use to extrapolate inference from similar tasks. I will maybe conclude this first session by saying that this question of inference costs, it's also the question of money, at least for companies. It can become absolutely unsustainable, even money-wise, especially when you use external services provider. It can cost from up to millions if you don't take that into account, because it just scales linearly. And if I give you an example for a client I've worked with, 5 years ago, 6 years ago, we had a system in production that was doing, as I was explaining, product sentiment analysis. And the goal was, for example, to see if the sustainable aspects of a product were understood by a consumer. We developed and we fine-tuned our model. It took us maybe a year in R&D, but then we had our own model that we could deploy and master the inference. So the cost and the cost in money and the cost in carbon was more on the construction of all the settings, but then it was a small model in production that was absolutely scalable. When we tried it again a few years ago, when the first version of ChatGPT came out, and we discovered that we could actually develop a similar system with just one prompt that was actually better than the things that we actually developed for a year in R&D. But if we have put that into production, it would just be so costly because it was scalable, and also so costly in terms of carbon that actually was not a good idea. And so right now there is a big trade-off in companies, in the research areas. I've seen many researchers just put into the bin all of their research in the specialized models, because GPT-4o mini was so cheap and so usable that it was actually better in most settings, that there is a huge trade-off in, do I want to own that model that will be easier to scale, especially inference-wise, or do I want to just use the AI service that I can actually have that could maybe be interesting in terms of inference if it doesn't scale that much, but can be just completely deterrent if it scales too much.
Well, thanks a lot, Theo. I think summarize it like, as you said, scale, complexity, and in so many ways, I'm going to over-summarize it as not value for money, but make or buy. Yeah. And it's going to be tempting to make a lot of this stuff, because at the end of the day, if you don't make anything, why are you a company? At the same, and we see that AI is so crucial. At the same time, it's moving so fast that you get displaced in terms of your value proposition. We are going to dive deeper in this question of small language model with our next panelist, Ana Paula Nisho de Souza from UNIDO, United Nations Agency for Industrial Development. So you are the Chief of Digital Transformation and AI Strategies there, Ana Paula. And so you've had quite a bit of experience to discuss and to understand how to help developers actually balance out these trade-offs that they have to face between deploying those large-scale models, or actually smaller, more specialized models, so-called small language models, so they are quite big too, to meet at the same time the quality and accuracy of predictions, and at the same time optimize, if not minimize, the energy consumption. Do you want to share a bit about your experience on that, and also maybe how it informs how policymakers should react to that, given the current and incoming incentive structure?
Thank you very much, Nicola. Good afternoon, everyone. It's a pleasure to be here. For the ones who don't know about the work of UNIDO, which may be many, because we are in Vienna, we are not a very large organization. We work, our bread and butter is industrial development, but I think what needs to be clear here that we're not talking about just manufacturing. We're very strong in manufacturing and smart manufacturing, but we talk to the industry at large, meaning the productive sector, including services, including all the value chain. So just in a nutshell, our priorities are N-word hunger, which I'm not going to cover much here. It's not the topic, but climate action and sustainable supply chains. And I'll get back to sustainable supply chains when I'm talking about the policy making, the advice for policymakers, right? And within digital, which is not listed as a priority, but is considered a cross-cutting theme for UNIDO. So we talk about smart energy, we talk about smart green, smart manufacturing, smart agro. Those were the topics where we have the most of our knowledge. So this question is two-pronged, and I will answer two questions wearing two different hats. So from the first question, I will draw from my experience from the trenches of tech, which is longer than I care to admit, but my gray hair betrays me, and talk about because I've been through many technological hypes and cycles and revolutions, right? From I will not say the first, otherwise you'll start calculating. But what stands is that certain principles stand, and they really apply to the discussion on large language model, large models, small models, environmental footprint. So, and I will use a very simple sentence that I've been using for a long time from the trenches of development, which is, do not throw an ace when a two will do. And what that means, be very critical and very conspicuous when you are developing a software. There is a question of architecture that comes first on what are the technology stacks and what are the best technology stacks that you need to use to solve a certain use case. So what I mean is, and I will use the analogy of the previous hype, which was blockchain. Where everything was supposed to be blockchain because blockchain. And of course, from a venture capitalist perspective, you're much more likely to get funds if you say you're doing blockchain at the time. And you're much more likely, for example, if you're working in ODA, like an official development assistant, if you're going to do an intervention, you are much more likely to get funds if you say you are doing blockchain. But that creates perverse incentives already, because each technology has its place. And this notion of AI, of course, AI is the new paradigm for software development. You cannot ignore, you cannot not use AI, but you need to be very critical on where to use it, because in many cases, much more efficient and much smarter not to use it, to use something maybe less sexy, but we will solve the problem in a much more environmentally friendly way. So that's the angle from environment, and that's the principle. Don't throw an ace when that you will do. So that's for architects, that's for requirements engineers, and you can still say you're using AI, but maybe not for everything at the micro level. So and when you decide, okay, that's the architecture, that's the use case, AI is the best fit for this use case, then the discussion moves a little further, which is, okay, then what kind of model do I use? Do I use a green model? Do I use a smart model? Do I use a big model? So of course, it's again, in that analogy, don't throw an ace with that you would do, which comes from some card game, which I don't know if it's poker or not. It's of course, a large model is more versatile and can solve many more problems, but for a specific problem, it may not be needed. You can either work with a smaller model, or you can, from the large model, prune it, or use distillation, or use techniques to make the model smaller and more applicable to your case. So the techniques exist. The techniques exist. There is people who can speak with much more proprietary than I do. So, but I think the principle stands. Don't throw an ace when that you will do, and that's and I use this for memorization, because we're going to talk about lots of complicated things. I'm going for memorable here, and that you will remember. So for the second part of the question, I'm going to put my other hat, which is more linked to my current job, which is about policy. So UNIDO in digital, in AI specifically, we work from a policy perspective in three themes. One is inclusion, which is about having to make sure that everybody can benefit from the benefits of the digital economy, that all the groups, all the countries can benefit. That's very big for us, but not so relevant here. And the second is the green, because the digital and the green are twin transitions. They need to go together. They need to go together. So we talk about how AI can make the industry greener. And then there is we have a lot of op-eds, a lot of things to talk about on how we can improve efficiency, how important AI and digital technologies are to green the industry, for resource optimization. And the other side of the coin is the greening of the industry itself, because AI is not green. That's the starting point right now. It's been a brute force attack. It's been the first models are very heavy. And of course, that's where the discussion is going through. So now I want to talk a little bit about what my other priority, which is sustainable supply chains, and the UNIDO view on AI. It's very holistic. So it could be that I'm either going to make this debate very complicated, or I'm going to get everybody very depressed. But when we're talking about training and inference, of course, they're all important. There's been a spike in energy use from the data centers, from all the companies in digital. So it's very important. But we talk about value chains. And we talk about value chains, this is just the use. So we need to, so from a point of view of policymakers, if they want to green the AI industry, they need to look at the entire life cycle. And that includes the data centers, and that involves hardware, but also involves the setup of the industry, because the AI is not floating in the air. Cloud is just somebody else's computer. We are talking about data centers. We are talking about hardware. And then we need to, so the discussion gets much more holistic and much more complicated, because we are going to talk about the cost of producing this hardware, which used to be 70% of the environmental footprint of digital. Producing the equipment is also important. And then we get into the discussion of critical minerals. Then we got the discussion of value chains, right? So, and then we go into the use, and then of course, then we have a lot of interesting conversations about how to reduce the environmental footprint of the training, which is something that UNIDO has some knowledge pieces about, and the environmental footprint of inference, which is also the knowledge pieces will come. And of course, last but not least, all this AI race is also making data centers replace, because space is also a commodity. So replace, and where does all the old hardware goes? That's also the other discussion. So from a policy perspective, I think my claim here is to make it whole, make sure that everything is there, and because it could be that you already have the bits and pieces to rule those, to have. Because of course it's also not an industry that just came out of the blue, right? It relies on the ICT industry. So there's been a lot of regulation on green data centers and what makes a data center green and what makes a data center not green. But you need to look at this from a policymaking perspective. You need to look at the full life cycle of the industry and make sure that it's holistic, and then you cover it all. Because otherwise, just looking at the use on the energy consumption or the water consumption throughout the use of the infrastructure creates perverse incentives, because it creates an incentive to change equipment. And if you're not measuring that, you think you're being green, and you're not. You're not, because you need to make the calculation of the entire life cycle. So I hope that that's a perspective that will make everybody depressed or make a lively debate. But thank you very much.
Thanks a lot, Ana Paula. And last anchoring perspective before we open up will come from Rosie Hood from LinkedIn. Can you tell us what you think are the specific skills that need to exist or that are already existing and that are mobilized at the level of those who develop, those who actually deploy these models, or those who actually use, like all of us, these models to help advance a world where these models are better optimized and have a more limited environmental footprint.
Thank you for the question and also for the opportunity to speak today. So for context, LinkedIn's economic graph is a real-time granular representation of the global economy. It's comprised of over 1 billion members and their activity. And we use it to kind of understand economic trends like workforce implications of AI, climate change, or inference, and how that's showing up among workers. So last year, we released our global green skills report. And in that report and research, we found that green skills were growing rapidly, and they were amongst the fastest growing skills among all workers. And we think that's because of 2 reasons. So the first reason is why we're here today. So it's the growing resource intensity from technologies like AI. And then the second reason is this kind of opportunity for AI to boost the green economy and to kind of help drive some of these climate solutions. And we're seeing these kind of green skills grow rapidly also in the tech sector. So in the tech sector, we have this huge spike in talent, but also in demand. So there's a huge demand for green skills now. And where we see that focus is in 3 kind of skill categories. So the first is corporate sustainability and environmental policy. The second is around energy generation and management. And then the third is around circularity. So to take an example, inference is contributing to all of those buckets. And one way that it is as well is energy efficiency, for example, was a top fastest growing skill in our report amongst many, many countries. And that's the idea of these kind of energy efficiency gains to drive or combat this energy demand. And, on the kind of user side or the skills that users might need, I'd say that you need to focus on this awareness of your participation in the AI lifecycle, and also that you are part of this ever-changing kind of world of work, and also, constantly evolving a world of skills. So we recently did some research where we showed that by 2030, 70% of skills required for most jobs are going to change. And that's being accelerated by AI rapidly. And we're also seeing more and more members on platform add what we call AI literacy skills, so things like ChatGPT. And we're also seeing now that being mentioned in AI in job postings. So the share of job postings that required an AI literacy skill grew by 6 times in the past year. So, users are having to adapt to this kind of world. So I'd say, to kind of end really is that, skills are contributing to this evolution of AI. It's important to understand that world, and it's important to track that world. So, AI's influence can kind of be best seen through this lens of skills. And we also, in part of my role at LinkedIn's Economic Graph Research Institute is also to lead our Data for Impact program, which is how we share data with multilaterals like yourselves and government institutions to make informed policy decisions like skilling initiatives. So if that sounds interesting and if our data sounds interesting, please do reach out. Thanks very much.
Thanks a lot, Rosie, and thank you everyone, Thierry, Anna Paula, and Theo. It's now time to open up to all of us, to all of you. It's now 2:13, 2:14, so we have until 2:40, meaning that we have not as much time as I would have hoped. But so therefore, keep your comments and questions to the point. Raise your name placard to ask for the floor. And when you make comments, try and be as operational, as actionable as possible in terms of what is it that you need to advance what you're working on in terms of policy, informed policy decisions, like Rosie said. And if no one begins, I'm going to put Boris on the spot. You see, because you've been
Yeah, thanks so much for having me. I don't have a name tag. I think I was a late addition, but I'm Boris Gemzachkov, head of AI sustainability at Salesforce. I think about how to reduce the environmental impact of AI within our product and kind of the wider ecosystem. So a few days ago, in partnership with Hugging Face, Cohere, a lot of universities, we launched the AI Energy Score. And so this is a project to try to, there's a lot of different ways we can measure inference, and we can start to dissect it. And we really wanted to develop a standardized way to begin to do that. Something I really want to kind of take a step back on with all of this, and even the concept of just talking about inference in isolation, is that AI has gone through a lot of evolutions over its time, and it's going to continue to do that. And this landscape is going to continue shifting under our feet. And yeah, I just kind of want to call that out. A few folks have talked about reasoning models, how those are fundamentally a different paradigm when it comes to inference. Before, with kind of the traditional LLMs where you have input and output, now there's an intermediate step that happens explicitly. But there are researchers working on that happening potentially in latent space. So, reasoning, aka compute, that's going to be used an indefinite amount of time in latent space that can't actually be measured. You mentioned continuous pre-training as a potential future paradigm, agentic use cases which call out to additional kind of external tools and external models. So I know that's a lot, but I think it's important to underline that where we are today, where it comes to these paradigms, is likely not where we're going to end up. And the way we design policy and the way we design our systems and standards to address these things should keep in mind that these things should be modular and should be made to evolve over time.
Maybe let me ask for a quick clarification, because not everyone is necessarily very familiar with what you mean by the latent space. So can you say a bit more in terms of why is this important? I want you.
Yeah, I might not nail this exactly, and I think there's a lot of different approaches here. But right now, models, when reasoning models think, they think out loud, and these are things that are perceptible through tokens. So if you go into DeepSeek R1, you can actually, when you ask it something, the model will then start talking to itself. It'll say, "Wait, no, I need to do this way." It's pretty odd, but that might not be the most efficient way. Sometimes you'll actually see them switch languages because they find connections in kind of in their embeddings that are more efficient. Researchers are working on that happening not at the level of language, actually, but at the level of, I think they might not understand yet either. So it's kind of at the level of the underlying data. So if there are standards that are in terms of tokens or in terms of something more concrete that's visible in the model, if AI goes into the direction of this more latent kind of symbolic representation, it might not be applicable. Yeah.
Thanks a lot. Sarah?
So thank you, Nicholas. I'm going to be the voice of the people who are online. My name is Sarah. I work at the OECD. So we have a couple of questions. So maybe what we can do is we can alternate between comments and questions in the room and comments and questions online. So I'm going to go with the first one, and maybe some experts in the room have this answer. Has there been any authoritative study or benchmark for a country, size, population, economy, to be sovereign in its capacity to host data centers that fuel demand on resources for expected growth in AI from people using only the resources provided by this country? So I'm not sure if anyone is aware of this kind of study, but this is one of the questions that was asked online.
Well, if I may just, I don't know if it will completely answer that question, but of course, everybody who's working in the space of policy is also working with to create more knowledge products and more quality data so that people can look. But I would like to mention, for example, the work of the Digital Cooperation Organization, who's creating the benchmarking for digital economy. That works with many. They are a new organization. They are in I think it's called the Digital Economy Navigator. That looks at the capacities, the STI capacities, and the private sector. So that's to name one. So then I will stop with one to see if somebody else has more to talk about. So we have Digital Economy Navigator that the DCO does, and there are other, I'm pretty sure OECD may have some interesting things to talk about, and so on and so forth. So I give the floor back to you.
Thank you, Ana Paula. And we do have a study, but it's looking at public compute capacity per country. So this is a report that's going to be published hopefully in the coming months. So this is the only paper that I can think of to answer this question.
Theo, you had something on this.
That's a really interesting question. But what I'm seeing right now in the industry is that it's a bit prospective because we don't have the possibility right now for algorithmic pluralism. That means that even if right now, let's say we have a lot of data centers in France or in whatever country and you want to run things on it, I have no possibility right now in all of the products I'm using to at least opt out of using AI, but also to redirect the fact that the computation needs to be in a specific country. So on top of that, in terms of policy, if you want those kinds of sovereignty discussions to happen, there is also up to the platform level, up to the product itself, and up to the way of making settings accessible so that we can actually make that kind of switch that doesn't exist right now.
Who wants to go next and share a perspective? You've all received some, framing questions to help us guide the conversation. We want to hear from you. We've heard from us enough.
Here. Yes, I'm Caroline Ganscombe. I'm an economist, so from the economic part. And I just wanted to say a very short comment about the models you are seeking. They do exist and they are published. Because and plus one, because what we use a specific aspect, which is looking at the features of AI. We turned them into ABC, activity-based costing, product-based costing. We looked at the full business models, and we obtained a cost. Because we're economists, so we are only interested in margin and money. Sorry, sorry for that. So we turn this into cost, and they are published in plus one. The data is accessible. So if you want to go more, well, it's open access, open source, and open usable. That's the first point. The second point is that when you're talking about data and this issue about available data, it's not only a question about accessing this data, but when we are talking about algorithmic pluralism, we have also the issue about algorithmic universality or algorithmic invisibility in a way. And it's not only the way the information is not only the important issue to get, but also how it's treated, and if all the features are adequately treated by the different kind of models. I'm saying that because we are working on massive data. We don't even need this kind of data sometimes. So we need to really understand that it's not the data, the accessibility of the data, which is really a request, but the adequacy of the data in a way. And I can give you a very short example. When you were looking at jobs, I was very interested about what LinkedIn said. When you're looking at job features and those kind of things, and you post, we are open to diversity. What is diversity? What is diversity for a large language model? They don't understand. So it creates, and when we had a very interesting from University of Manchester, not Birmingham, there was this very interesting study saying, well, using this kind of non-very defined data, you're losing 70% of the talents if you use algorithmic system to get access to the workers. So the question is not large data access. The question is, and it might be an overkill to have those large data access, but it's not only the adequacy of the model, but it's also the adequacy of the data. And us in economics, we have massive issues because we don't have the same understanding of what we are looking at. When you look at deep trading and markets, you have different definition, different vision, different type of outputs, and it's never, ever standardized. Everybody says, oh, the data are standard. No way, never. We have at least looking at this very simple deep trading aspect, quick trading. We have at least 78 definition of the different outputs.
Your job is safe.
For now, just for now. Do we have another question?
We do have a couple of questions. People online are very active. So this one has some sort of a context, so please bear with me. The burden on the planet is such that AI data centers are believed to account for as much as 2% of global electricity consumption. In December 2024, and this is a follow-up to what Boris was just saying, DeepSeek released its V3 language model and followed this with its R1 model. And it's V3 that is causing actually the excitement, and its cost is reported to be 4.4 million to train and develop. 4.4 pounds, I should say the currency, which is a fraction of what OpenAI needed to make the ChatGPT-4, which reached more than 80 million pounds. So DeepSeek says it only used around 2,000 computer chips, far fewer than the industry average of 16,000 chips, which are used to create a similar open source AI platform. So I'm not sure if anybody has comments, because this is something that has been launched in January. Like, what is the room perspective around the efficiency of DeepSeek?
Just can you give us a bit of context? Who is it? Are the people online? You know, do we know where is this question coming from? If you anonymous, okay. I think Theo, do you want to take this and maybe also we're talking pre-training here, not inference. It's a good opportunity to clarify here.
Yeah, because there's really a different question between training and inference. In the case of DeepSeek, it was kind of proven that maybe it was more energy efficient, like less GPUs, what was disclosed at least. From the inference part, that's what's matter at least right now. So it's not that clear that it's actually more energy efficient, and for sure it's not going to solve anything about energy crisis or environmental crisis. DeepSeek R1 at least use a very interesting architecture that was popularized by Mistral called MOE, a mixture of experts that basically is not using everything when it's answering a question. So it's just activated at X% of the different parameters that are in the AI model. It's actually quite interesting, but on the size of those kinds of models, and especially with the reasoning part that we explained, it was proven by outside analysis, especially one that was maybe the only one that we've seen so far by Scott Chamberlain from the Green Code Foundation, that made a really interesting study on what was the actual impact of DeepSeek. And basically, even if it's a bit more efficient when it's answering a question, because it's thinking out loud, it's actually just thinking for more time, creating more tokens. So it's at least 86% more energy consumed, and up to 6 times more for a similar question, because it's not actually doing exactly the same thing. So it has been done and replicated because now it's open source. So at least we can actually do that kind of measurement. But the DeepSeek question had actually created like a whole acceleration phase on reasoning models that is actually causing a lot of questions on the inference impact, because now it's not just maybe more words. We actually don't really know how much the model will think. And for example, if I ask a question on how was the universe created, I could let it think for maybe hours and it will still compute and use GPUs. So the inference cost will be so high. So actually, it's really different depending on the model, it's depending on the question, it's depending on the task. DeepSeek in itself had a really architectural model that was interesting in a way, but the reasoning part introduced it to the market with the rebound effect that it created had actually not a really great impact on the energy right now.
Yeah, thanks for mentioning the rebound effect. We've discussed a little bit, not that much the Jevon paradox, but this one is different, the rebound effect, which is a different think. Anna Paula, you want to add, and then we'll go to Karine.
Thank you. Just the technical perspective also very, very interesting, but just a little bit about the economic perspectives. The notion of having more efficient models, I think is very positive. Without knowing what's going to happen in the future, I think it's great that the industry is being compelled now to become more competitive and have more efficient model. Even though we don't know about the inference yet, this is still a no, but I think it's very positive that it's moving in that direction, because of course there was also the system of incentives playing with the private sector, because it was in their best interest to keep AI expensive and big, because you could attract more venture capital this way. So and it's good that the logic has changed, and I think it's something that of course you never know the consequence of the consequence of the consequences, but the notion that AI doesn't have to be enormous, doesn't have to be a brute force attack is very important. I think it's in overall a very positive development. Thank you.
Thank you very much. Several things about DeepSeek. The algorithm is actually open source, but open weights. But the point is that it's not the way it was implemented seems to be a bit, well, obscure to say. So there is a difference. And when we talk about AI, of course we have the algorithm, but we have the value chain, as you said, and the whole value chain is not completely available concerning DeepSeek. The second thing is that when you talk about resource efficiency, which is something that is absolutely vital, it is what we call how can I say, job-related AIs. It's something that is also it is absolutely clear that you can be frugal and you can be absolutely cost efficient when you develop AI. You don't need big centers, you don't need big volumes. You just need to have something that will answer your need, which is something that we see in economics. And you don't be, I mean, sometimes all those big things, they are overkills. You might need them, but for simple SMEs or for simple issues in companies, you don't need monsters. You need simple tools that you can use and that are data efficient. And the third thing I wanted to talk about is data minimization. Everybody knows about data minimization. And it's something that we need, I'm talking about under the TOS control, it's something that we need to, I believe, to really promote. Because when we talk about the business process, when we talk about, again, I'm sorry, I'm biased, but when we talk about money, in the end, the less you use data, the more efficient you are, well, the more margin you get. Sorry to say so. Thank you very much, sorry. Just if I can, just one, sorry. With the models we've developed, and it's not too broad, we've managed to reduce the resource usage by 34%. And when we look about AI used in social media, we managed to reduce the resource need by 90%.
Thierry, would you like to add something?
Thank you very much. Yes, I think we are still in the process of really fully grasping the consequence of the DeepSeek revolution. There has been a lot of studies coming up in the recent days in amazing results in optimization of large language model using less and less training. I wish I had an internet connection. I would be able to give you the exact quote and reference of the study, but I believe yesterday there was, I think, a paper from Stanford University where just using 1,000 questions across 50 different areas of knowledge, they were able to train a fine-tune model in such a way that it had performance on par with a much larger language model. And the process that they used was every time that the model was giving an answer that was incorrect, the only token that was being output back by the system was wait. Like, you know, when somebody gets it wrong, you say, have you really thought about it? Wait. And it would go on inferring until the moment it reached the right conclusion. And that simple methodology was enough to get a system with only 1,000 questions on par in performance with amazingly good other system, much more costly in weight. So yes, just to finish on that topic, at CSAIL, we really believe a lot in creating systems that are built at system level. AI is wonderful, but as much as you can use it in a very constrained and defined environment, not asking it to do magic for you. It's not a black box. You don't just give it the footprint of 1,000 rows and expect it to do magic. No, you construct very strictly defined pipelines and only use it in very precise moment of your pipeline for scale. Other things that can be done for optimization, let's remember that a basic caching of your queries can do wonders for you. If you ask the same question 1,000 times, why ask inference every time? You can cache it, and it not only increases decreases cost, decreases environmental impact, but it also addresses a fundamental question that we have with generative AI, which is the fact that it is generative. So if you ask the same question twice, you might not have the same answer, which is kind of a problem when you're measuring a carbon footprint. So this also is something that can be done. And also, finally, self-hosting your LLM is definitely a recommendation that I would have for you. We were just addressing a couple of minutes ago the fact that when we are asking a big company to do some inference for us, we don't necessarily know where the inference takes place. Well, I'm no spokesman for AWS, but it so happens that my company runs its infrastructure on AWS. And we, in fact, know exactly where inference happens. We can actually, for each client, define not only a main region of inference, but also they have a concept at AWS where you have cross-regional inference. So after a while, when you have more queries that are too much to handle by one given geography, you can decide, okay, well, I accept those other regions for inference. This is certainly not as granular as we wish it would be. We would love to have granularity at the level of the data center. We are not there yet. But I believe the industry is moving in the right direction and giving more and more control to the clients. That's what I wanted to add.
Can we go back online, maybe, Sarah?
Sure. I'm going to skip one question because I think it's more related to the panel that's going to take place in 5 minutes. So I'm going to go to Guido de Moor from the Dutch Ministry of Economic Affairs. Thierry made the point that inference may have costs, but not using AI comes with costs as well. Are you familiar with research standard to put some quantity on the cost of not using AI for certain tasks?
I believe this is the point I was referring to. Yes, well, we would love to have more precise data on large language models so that we are able to exactly compute the sustainability cost of matching a 300,000 rows activity footprint using AI. But I know we have enough emission factors to measure what the impacts are for using 4 BCG consultant during a month and a half. And I can tell you that I don't have the exact figure in mind, but I think it's divided by 100 in terms of environmental impact. So there are certain tasks that when they are very repetitive, when they require a high level of understanding, they cannot be performed by anyone. AI can do wonders for you into decreasing, but this is a case-by-case analysis. I cannot give you a generic answer to that question. I'm not in position to do so.
No, if I may, I think that the question needs to go, I think the analysis needs to go back to what I was mentioning before, which is the use case. For every use case, AI may be a solution, or there may be a better solution, so that has less environmental costs. So I think it's a matter of being very, very critical and look at the use case, the problem that you're trying to solve. Still going back to all the engineers, we're just solving problems here, and see if AI is the best tool or the best way to go about it. So at the generic level, yeah, that's a very difficult question to answer. We don't really have an answer. I don't think anybody here will have an answer. But once you go down to the specific use case you're looking at, and if you look at the more environmentally efficient solution that solves the problem, I think you can't be wrong with that. Thank you.
Yes, to go with Anna Paula, the business case, we've done a number of business cases. One we managed to complete is about the chocolate industry, because of Charlie and the chocolate industry. So it was a humor, a little sense of humor of researchers. And sometimes they do have a sense of humor. Anyhow, so what we did was what we managed to do. We took a number of business processes, industrial, very specific business processes, and we specifically looked, because we have this activity-based costing. So we have the breakout of the activity. We managed to look and to in a way arbitrate between what was AI needed, where was AI not needed, and where there was an arbitration to be made. What happened is that if you start to use, those are the results that are going to be published soon, where whenever you use AI in a process where it's not needed, your costs are absolutely going over the wall. But it's not minimal. It's massive in fluids, massive in consumption, massive in redesigning the business process, because AI is also impacting the business process. and the satisfaction of end users. So you have those kind of elements that really need to be taken care of. That's the first point. The second point is when you use AI and it's needed, again, what you said is true. The prices are going really, really, really low. So, and in the end, when you use AI, when you need an arbitration, it's only, again, in the end, a question of margin. Because in the end, what the company wants is enhance their margin. They want to satisfy the end user, and so we use marginal utility for this, and they want to satisfy. They want to enhance their margin because they want also to satisfy their stakeholder. So it's not a question. I mean, AI is not a technical question in a way. When you talk of AI in economics, the question is AI going to implement and to make possible margin enhancement or not? And the arbitration will be there. It won't be technical. They will say, well, do we gain money with this thing or not? Do we gain productivity? Or if we don't gain productivity and money, they're simply not going to use it.
Be as short as you can, because
Pierre
will
10 seconds. In this race for performance, let's not forget there is such a thing as a good enough model. For us, using the models that we are currently using at C2AI, we have reached a point where they are totally satisfactory to us, and we are in a very fortunate position where pretty much the only aspect that we are now monitoring is sustainability. We just want to get the next model, not that it improves performance because we're already at a very satisfactory point, but that decreases sustainability. So there is such a thing as not overkilling the problem.
Hi everyone, my name is Pierre. I'm a researcher at Sciences Po University. I'm also working with the Word Sufficiency Lab created by PCC author Yamina Saheb. I think it's a very odd question, and I think we can all agree on this, is that like asking this in a general manner doesn't really make sense. Indeed, there is a case-by-case approach, but there are ways to navigate this. And the first one is, are we talking about a need for which the AI model that is going to deploy this general purpose one, or is it a specialist one? And this already creates like dramatic, very different environmental impacts. I'm working a lot with Institut Pasteur here in France, so working on biotechnology research. And in this case, of course, they have very, very specialist models that replace some lab work that can at least like that enable simulation of sometimes lab work that would be very, very long. So in this case, obviously, there are some environmental efficiency gains, but it's lab work, right? Like it's definitely not an industry that is worldwide and super global. And in any case, those are results that are published open source and replicated. So just mentioning that, although this question is very weird, distinguishing general, is this a need for which I have a specialist model that is open source, whose training does not need to be replicated across industries, across teams, or do I need a general purpose models for which we just discussed the inferences can be enormous, is probably the best answer we can give at this stage. And just to mention the work of another French researcher, Gauthier Roussine, who I believe is presenting his PhD very soon, but I invite you to check out his work. He published a couple of regional assessments of the environmental impact of digitization, and those digitization in specific industry equals efficiency gains in terms of environmental impacts, and how do you factor in the rebound effect. And in the regions that he was solicited to work in, his results are mild at best. But once again, it's very region specific. So go check out Gauthier Roussine. On top of that, he's great at writing about his work in very accessible terms. So
thanks a lot, Pierre, for the closing words, and thank you everyone for participating. I will now hand over we are running over time. Can we use a bit more time, Sarah? It's 2:44. Do you want me to close it or final words? Fine, let's go. Please, Jeff, word over there.
Hi, everybody. My name is Jeff Ward from Animici Indigenous Technology. I support Indigenous communities in North America, supporting Indigenous data sovereignty. And I was really pleased to hear other impacts around like economic impacts and how we might maybe measure this as well. This is, hidden costs of AI with a focus on environment, energy, and water. But I'm curious if anybody has measured or considered adding measurements of socio-technical and economic impacts, for example, with Indigenous peoples. Anna mentioned the cloud is just somebody else's computer. And something to add to that might be the cloud is also on somebody's Indigenous land somewhere. And so it'd be interesting, I'm hearing in measuring the whole stack from the hardware level, system level, inference, and even measuring the cost of not using AI. That was really interesting. But within the Indigenous context, I'd say I'd also encourage those looking to measure environmental impact to include Indigenous voices, because Indigenous peoples globally are the original land and water protectors and need to be consulted from a rights-based approach, and I'd say even a human rights approach. Some of the Indigenous groups that we're supporting with are telling us that they are literally fighting data centers on their lands. So I just wanted to leave that in as an offering of maybe considering the socio-technical and economic impact on Indigenous peoples. Thank you.
Thanks a lot. Great play on social technical. Everything is social technical, in my opinion. All right. Well, we can hand over back to Clara and Sarah for the second roundtable.
Thank you, Nicola. Thank you for this very interesting first round. I would like to hand over then to Arti Garg, who is the chair of our working group, so IEEE working group, and to moderate the second session on the impact of data centers on the electricity grid. Thank you.
Thank you so much, Clara. I do have a question. Were we able to get Tom and Ian on? They are online now. Okay, so we are still waiting for Alexei, but I think we'll just get started. And once he joins, we'll add him to the conversation. But before I start this session, there are some other open seats. So if you're in the back of the room, please come up. We want to have, I would love to have you guys make my moderation job very easy by asking lots of questions. So please join us at the table if you see an open seat. But otherwise, let's just get started. So the topic of the second session, and I would love to keep this as sort of more casual discussion, is the impact of data centers on the electricity grid. So we're sort of moving from what I would say is a much broader discussion on environmental impacts of inference to maybe what sounds like a very narrow focus of data centers and the electricity grid. But I thought that this was an important topic because it actually starts to raise many other topics once you start to think about electricity and some of the other challenges we have around electrification, including, since Jeff just closed the last session talking about impacts of data centers on Indigenous lands, you also see with the migration of electric grids off of fossil fuels into renewables, often there's other land use questions that come up with Indigenous communities, such as mining for rare earth metals, or lithium for batteries. So I think this is a very interesting topic. I'm going to just set the stage a little bit why this is so interesting is that, we heard, I think in the last session about right now electricity demands for AI. Estimates are difficult to come by. Nobody agrees. Maybe Brendan will talk about some of the announcements that IEEE has made this week that might help with pinning down those estimates a little bit more closely. But one of the things that I think there's no disagreement on is that the demand for electricity by data centers is growing. And so current estimates, I get numbers from 1% to 4% is what total electricity demand that comes from data centers is today. But this could grow over the next 10 years, estimates anywhere from 3 to 6 times, maybe even more. And so we know that data centers are energy hungry. In particular, they're hungry for electricity. And so they are putting stress on our electric grids. This is happening at the same time that that most countries around the world are in the process of transitioning off of fossil fuels into renewables, and renewables pose their own challenges to electric grids. Their intermittency can make grids a little bit more difficult to manage and keep stable. We also have a lot of parts of the world where electrification is still underway. So you have many communities around the world where access to electrification 24 hours a day, access to electrification for all of the different applications you might need it, isn't available yet. And yet we are putting more stress on the electric grid through data centers growth that is being driven by AI. In addition to that, we're also electrifying many other areas such as transportation. Electric vehicles are also putting stress on the electric grid. So this conversation is happening. I just want to set the stage at a time when already industrialized countries are looking a little bit more at how do they update their electric grid to accommodate changes, and then other countries that are right now realizing 100% electrification are thinking about how do they manage their grid and how do they develop their grid for the future. And so I think this is a really interesting question to understand where is AI playing in this much larger question we have right now with respect to the fossil fuel transition, and also with respect to really how we're developing technologies across the board, not just AI. So that's the stage I want to set. That's why I thought this was an interesting discussion to have. But I really would like to now turn it over to our panelists. I've asked them all to give 2 or 3 minutes opening remarks on their thoughts on this topic. And then I do have some questions prepared. But again, I'd love it if you guys could all make my life easier by asking your own questions. So I'm going to start by turning it over to Brendan Reidenbach. He's an energy policy analyst in the Office of Energy Efficiency and Inclusive Transitions at the International Energy Agency in Paris. He leads the Digital Demand-Driven Electricity Networks Initiative, or 3DEN for short, and I'll let you talk more about what that means.
Thank you very much for the introduction, and I'm glad I got here for most of the first session. It was really interesting. It's always good to hear the kind of what else is happening in this particular this sphere. There's a lot of change going on right now. I sit within the Office of Energy Efficiency and Inclusive Transitions at the International Energy Agency, and I'm the lead of the 3DEN project. That's Digital Demand-Driven Electricity Networks. And in this project, it's been running for over 5 years now, and it's just been extended for another few years. We do a lot of research analysis and provide policy recommendations to our members on the challenges and the needs for power system modernization in this era of flux and change, as Artie's pointed out, to the changing supply side with the growth and deployment of renewables at scale, but also the changing demand with increasing new loads on electrification of buildings and transport, and also increasing digitalization. And I also manage a part of our output at the agency called Tracking Clean Energy Progress. And in this, we monitor 50 key items, critical path items that are necessary for countries to consider on the pathway towards a net zero world. And within the IEA as well, within our analysis, we take a couple of different paths on how we look at the energy landscape going forward. We look at this through the lens of different scenarios, through the announced pledges by governments, what they say they will do, the stated policies. So once policies have been announced, are they being implemented, and what this might look like in the future, and then the net zero scenario. And this was established at a landmark report released back in 2021, where we looked into what was necessary to transition every part of the energy system towards a carbon-free alternative by 2050 to prove if this was possible within the limits that we have. And with this analysis, the report was released, and it stated that this is possible. The technology exists in a lot of the occasions, but it just needs political will. So coming back then to where we are today with the discussion on data centers, I think we've seen
digitalization becoming much more prevalent across many different countries as they're becoming more modernized. The growth of electrification is happening as well in parallel. But we've been monitoring data centers for over 5 years now by looking at how they fit into the ecosystem as the supply side, how they're sourcing their energy, their total energy consumption as well, and then tracking the policies that are related to data centers. And I've heard some of the numbers being thrown about here today, and most of those are our numbers that we've been looking at. And it's great now that everyone is finally interested in looking at that on a global basis. And as I said, it's over the last decade or so, energy demand for data processing has remained moderate and relatively unchanged at around 1 to 1.5% of total global electricity consumption. However, in the last few years, we are seeing that there is a change and there's an upward curve occurring as more and more sectors of the economy and society are becoming digitalized. And with that then is a digital footprint. But I think to manage kind of the reality of the situation is that is still a moderate growth compared to other sectors. So if we're looking at the historic, we can see that it has remained relatively consistent. Looking at where we are now currently is that there is change, but it is a slow growth at a global level. On a more regional basis, there are different changes and challenges that some countries are adopting digitalization much more quickly than others. Some regions are without the ability to move towards a digital economy. They lack the resources, reliable power grids, for instance. And then even within the regions, we can look on a more national basis. Some countries are running into some challenges where they have perhaps moved at a faster pace than their institutions were able to manage. And then on a more local basis, growth can lead to challenges on a local power grid situation, leading to constraints. And then I suppose just to kind of end this initial intervention is to say, like, where are we right now? We know there's growth. We don't know how much growth, and that is, I think no one has a crystal ball that will tell us exactly the amount of digital demand that is going to be expected in the coming years. But we do know it's increasing. But it's not as the growth for electricity for digitalization and AI and advanced analytics and data processing is not going to be the largest growth sector. That is still going to be the traditional sectors of buildings, of industry, but also now of electric transport. But it is important that we still do focus on this and look at the ramifications as well, because as countries become more and more digitalized, even though that electricity consumption itself is relatively small comparative to many other sectors, the effect of digitalization actually has an outsized footprint in economies. So it is important that we do focus on data centers availability and also how they can be managed in a more sustainable way going forward. So I'll stop there.
Thank you so much. Thank you so much, Brendan. Now I'm going to actually turn it over to two of our panelists who are online, Tom Jackson and Ian Hodgkinson. They're professors at the Loughborough Business School who founded the digital decarbonization movement. Their digital decarb toolkit is the first open source resource to help organizations engage with AI responsibly and realize net zero ambitions. I just invite you to share your thoughts on the topic of the intersection between data centers and the electric grid.
Thanks, Artie. Yeah, sure. Often, I think we overlook the fact that data centers, despite their substantial resource consumption, provide us with essential services. So as users, it's crucial to consider how we contribute to the increased power demands. And maybe we should start to look at digital decarbonisation from a consumer perspective. Recently, we developed a data doomsday forecast by analysing past trends in data growth, data centre consumption, and electricity production. This forecast, though, assumes no future interventions, such as more efficient AI models or reduction in data consumption. Our findings, though, are stark. By later this year, there will not be enough renewable energy globally to power all data centres. By 2033, the energy shortfall will become even more pronounced, indicating that conventional energy sources alone will be insufficient to meet the demands of data centers worldwide. The data journey lifecycle encompasses, as we know, storage, networking, and compute, and can be likened to, I suppose, mining for gold within organizations. This gold, our vast data reservoirs, does hold immense potential value. However, the cost of mining these data and the return on investment require careful considerations by the end user. We are faced with exponentially growing gold heap, our big data lakes. Yet, as these lakes, I suppose, expand, extracting value becomes increasingly complex. It demands more energy, and as we know, more data does not always equate to better insights.
And building on that point, so as recently reported by Gartner, data storage alone could account for nearly 40% of the total estimated electricity use of data centers by 2030. So that is about double the amount in 2022. So this increase is in part due to the sheer and huge explosion in global data creation, which is set to increase from around 175 zettabytes to over 2,000 zettabytes by 2035. So a consequence of this is that organizations are reporting stress to their bottom lines, with additional storage costs already being passed on. So there's a real and significant financial pain, as well as, of course, negative environmental impacts attached to this acceleration of data creation globally. Given this context, Tom and I have been really emphasizing the importance of thinking through and about data waste, which poses a significant challenge and threat moving forward for organizations and the wider AI infrastructure. The need for responsible data management in AI development raises some important questions. For instance, AI systems are inherently data intensive, and this increases the costs involved. But do we need to store all the data that is generated in the training and deployment of AI models? What are the minimum viable data required for training? How is data managed throughout the AI lifecycle? Are redundant data like training data disposed of, or at the very least placed in the most cost-effective storage option? So thinking about AI and energy in this way, asking questions like these, has the potential to save organizations money, whilst also helping to reduce the environmental footprint of AI.
Thank you both, Tom and Ian. Now I'm going to turn it over to Maud Texier, who's the Global Director of Clean Energy and Decarbonization Development at Google. In this capacity, she leads the Technology and Solutions Development Group, working toward decarbonizing Google's operations by 2030. Thanks.
Thank you, and thank you, Artie, for having us on the panel. I attended part of the previous panel, and that was very informative. Just to set expectations, I'm more an energy person than an AI person, so I'll do my best. But I have a colleague of mine who is more technical on the model side. So for those who are not familiar, Google is a large data company with a couple of services serving billions of users, and AI has been kind of the core, I would say, and the backbone of our activities for a decade or more. But electricity has been really also at the core of this activity. And that's why, today we're on this panel is to give you a bit of an overview. I'm spending a lot of my time on decarbonization of our operations. And what that means is decarbonizing data centers. And what that means is finding clean electricity as much as possible. Just for a couple of points on history for us, we started our journey on clean electricity around 2007, where we signed our first power purchase agreement of renewable energy, which was for a wind farm in the US. And since then, we've been on that path to acquire and purchase clean electricity around the world. We now are aiming towards our 2030 kind of milestone, which has two two angles with a lot of intersection between those two. The first one is a program that we call 24/7 carbon-free energy, which resides in finding clean electricity for the data centers where we operate and when we operate them. So what we call then hourly local matching of our energy consumption, and we can share more about that. And then the broader program for us and achievement is what we call net zero by 2030, which is a reduction of our greenhouse gas emissions across the three scopes, scope 1, 2, and 3, and then with a program on carbon removal to help us offset the residual emissions by 2030, because we have to admit we will not be really carbon free by 2030 across our operations. And so as it pertains to AI, Brendan talked a little bit about it already, but data centers have been a growing asset class on the electricity grids for more than a decade now with the era of digitalization. And we see an acceleration with AI and ML demand, but that's also why I think we need to double down on efforts around energy efficiency and clean electricity. And so today for the discussions, maybe just a couple of ways on how we typically structure those discussions and those programs for us. So first of all, the way you can look at areas where we can tackle those problems, there's like 3 or 4 layers from my perspective in the data center infrastructure. The first one is the models. So we talked a lot about it in the previous panels, but making them more efficient, the trends to like smaller models as well is very interesting. The second one is more the hardware, the machines that are actually running those models. We've been doing more and more work on getting them more efficient, and we can talk more about it as well. And then the other layer is the data center as a building or as an envelope, right? How are you making sure that the whole operations is as energy efficient as you can? There's a couple of metrics that have been standard in the industries, and we see good progress there, so happy to chat more about that. And the last one is electricity consumption, because again, even if you're highly energy efficient, you're always going to consume electricity. So what do we do to find this local low carbon electricity where we operate? It is a challenge. I don't think we can deny that. There's a lot of stress right now on a lot of grids. That's a very local challenge as well. There are specific regions in the world where this is a real issue. But, I like to see the glass half full. I think that's also a way to really be a catalyst, right? And accelerate a lot of the investments in the clean energy transitions. And just a point for you in terms of where I see we can really, garner a little bit of this investment pathways is, if you look at the role of corporates in accelerating clean energy investments since 2008 to 2023, I think we're just under 200 gigawatts of PPAs signed across the world for wind and solar. So this is just an example of where I think we can spend more efforts and really align interest and schemes to help funnel these investments in the proper places for grid modernization and grid decarbonization.
Thank you. Thank you very much, Maud. So I would love to open it up for questions, but I want to maybe kick it off and invite all of the panelists to respond. Brendan, you said something toward the end of your opening remarks that sort of struck a chord with me. You mentioned that while data centers may never be sort of the primary or the most important source of electricity demand, digitalization has an outsized impact on economy. And I think that, to me, that's very interesting because it starts to highlight some of the reasons why this interconnection between data centers and the electric grid is so important. Because, and I'll share, I used to also work in microgrids and renewable-led microgrids. And one of the challenges is you can build a microgrid that meets 99% of your use cases, but that 1% is usually where maybe there's some other type of catastrophe going on and you really, really want to be able to have electricity. And so you talked a little bit about high availability. Data centers may not be the largest demand on electricity in terms of aggregate energy consumption, but they may have an outsized demand in terms of wanting to be the most important load. And so these are other questions that I think grid operators, grid developers need to be considering as more and more data centers come online. And in the US, we've already seen in the Duke Energy territory where a lot of new renewable capacity coming online was being taken up by data centers. You ended up having to have a agreement between large corporates and residential users to ensure residential users had primary access to that renewable energy. So I invite all of the panelists to sort of give me your perspectives on this this notion of the fact that data centers may not be the largest source of electricity demand, but they may really have an outsized importance and take priority over other types of electricity demand. And I'll open it up to Brendan first.
So yeah, I think it's a really interesting kind of dynamic. Whereas, as you said, it's not the largest load on a national basis, but it is strategically very important to have access to data centers and data processing. Because I think you'd have to look at the current situation in some regions, the challenges that are being experienced where there may be insufficient investment in grid capacity. So therefore there's constraints, there's insufficient ability to move electricity around as needed. And this could be from existing data centers, or it could be the inability to connect to new data centers. And then this poses challenges as when we look at the data sovereignty issue, particularly when we look at GDPR, the data that is produced within the European Union must be maintained here. So if there isn't sufficient capacity to provide that data processing, how is that going to be managed? That then creates much more wide effects. But it also, on a kind of more macro level, it does put business and government and the citizens directly in conflict, because we're putting this issue of which gets primary power. Is it going to be a new data center, or is it going to be new housing development? So then this comes into that wider question of future thinking and how do we manage this situation, and what can governments do in this situation to make sure that this can be avoided going forward. Moving away from the supply side as well, aspects of how to make this more sustainable. I think it's also more important to look at how can we make sure that the demand can be met, because ultimately society will become increasingly more digitalized. We're not going to reach that point where we decide to go back and everything becomes paper and analog. We are in this situation right now. So it is important to look at the reality of the situation and then think at how it can be managed to reduce that effects.
Thank you, Tom. Ian, Maud, any other thoughts?
I can go, yeah, or Maud, do you want to go? Okay, yeah, so agree with Brendan to a large degree. But we've got to think about, you've got data centers, you've got on-prem. Are we going to move totally away from on-prem? We've got all the ICT costs that generally society use. So it's right in terms of government, in terms of forecasting. In terms of our forecast, it doesn't look good unless we make some interventions, because then you've got to be making a decision between, it's extreme, I know, but if we say we're starting to remove some social media platforms because they take up too much energy in data centers, how does the general public think about it? So yes, it's a really extreme case, and you can say, well, that's just rubbish, but it's a potential that could happen down the line. In terms of, we keep on building and building these data centers, and they're just servicing us, the end customer, really. But we've got to think about ourselves in terms of organizations that we work for. And in particular, the AI models that we're trying to develop and the KPIs around them. What are we trying to achieve? And I think there's a lot of wastage in terms of the data sets and the dark data that we have. So there's lots of energy efficiencies we can make through our decisions on how we deploy AI and the data sets that we actually use.
And just to quickly pick up on Tom's point there. So scaling of AI is obviously very much on the global agenda. How we scale when we are able to recognize that there will be capacity limitations moving forward is very problematic. Now, one way to approach this, as Tom touched upon, is by reducing the inefficiencies now, and by removal of the likes of data waste, identifying dark data, and the like, we begin to free up capacity. So we both can support the scale agenda whilst also reducing the associated and often negative environmental footprint. So the two don't have to sit in conflict. They can absolutely complement one another.
Yeah, thank you. And I'll maybe take another aspect of the question and, to rebound on Brendan as well, which is how do we make sure that we plan more carefully so that this is not one versus the other in terms of like which new user do you serve with clean energy? And again, for me, the idea is how can we maybe bring more like things like public-private partnerships, right, from that direction, and really plan together at the national level in terms of like where do we sit and how do we sit those this new infrastructure, but also can we have hyperscalers and other data centers providers bringing their capacity? And so this is part of the new commercial avenues and schemes that I think we should incentivize to again bring those investments to the tables, because the investment is available. There's a lot of money announcement every day, right, on data center infrastructure. And I think we just need to funnel it in a way that is efficient from a grid planning perspective, but also a user perspective. Just a quick example of a structure like that we found is it's in the US, so it's under a slightly different utility tariff and mechanisms than what you would find in Europe. But we work with our utility in Nevada to develop something that is called the clean transition tariff. And basically it enables a large users or large load like Google to invest on a specific clean power plant. In this case, it was geothermal for us, which most likely would not have happened otherwise, or would have happened by increasing the cost for all of the users on the grid. And so this way, Google is directly paying for that premium. In exchange, we're receiving the benefits from it in terms of like clean attributes, but also the added capacity to the grid. But again, we were ready to do that because we needed to grow. We had a time to market commitment. And I think, again, with the market spur that we're seeing right now, there is an incentive to funnel those type of investments. So we should find the commercial models to help funnel those type of investments and bring those new stakeholders to what typically has not been necessarily where they've been investing in the past.
Thank you. I'd like to start by opening it up. Are there any other questions in the room, comments? Anna Paula.
Thank you, Artie. My question for the panel is, of course, when we're talking about the environmental footprint of data centers, the choice of location and the energy grid that is available to you is of utmost importance. And we know that when we come to renewable energies, that it has the drawback that is not a constant supply, because the sun is not always there, the wind is not always there, so there isn't it's not necessarily it doesn't fit the whole bill, right? Because it's not constant, and in that case, data centers tend to fall back into traditional and more environmentally heavy energy sources to make up for the difference, right? To make up for when the renewables are not available, the energy come from renewable sources is not available. So there is a growing discussion now there is already a lot of a growing discussion on green hydrogen now, which is used primarily in hard to abate industries, and I think AI will soon look like a hard to abate industry at this pace. But it's something that we look at for cement, for steel, for plastic. So what we call the hard to decarbonize, because you cannot electrify these industries. But we have an emerging discussion on using green hydrogen also on data centers, because the energy consumption is very high and the renewables not always available. So my question is, do you have an opinion, or what are the plans, or what are the studies in that direction for the panel? Thank you.
Yeah, I can start. And we spend a lot of time on that topic because, yeah, we have this hourly approach with 24/7. And to your point, we need to find what we call clean, firm, dispatchable energy. So for us, there are like two categories of solutions we're looking in our portfolio. The first one is this high capacity factor dispatchable type of assets. And so that's where we're going to find things like enhanced geothermal, advanced nuclear, carbon capture and storage to some extent when it's with the right environmental constraints. But those are kind of like high capacity factor. We still see renewable energy as a majority stake, I would say, in the portfolio of resources that we will find because their levelized cost of energy is very low. But to your point, they're not dispatchable and they're intermittent. And that's why we need to complement them with storage and flexibility. So for this bucket, from our perspective, will be made out of external assets, so energy storage, but also things that are more inside the fence for us. And for instance, we're working on things like demand response and load flexibility at our data centers. So we're not going, data centers are never going to be a completely highly flexible assets, but there is some flexibility. There are also ways to build more on-site flexibility in general. So I think we should work together on incentivizing more of that. And on the more external solution side, so energy storage, I put hydrogen in that bucket actually, because from my perspective, there's been a lot of discussions and a lot of efforts around green hydrogen, and we're very supportive of those. But we also have to realize that the economics are sometimes challenging, right? In the case of hydrogen and green hydrogen, you take electricity from renewable energy, transform it into hydrogen, transport, and then transform it back into electricity. So for instance, for like a baseload solution, I don't see the economics penciling personally, and that's not part of the, let's say, the base case for us. But we've seen some example where green hydrogen is starting being cost competitive more as a peaker replacement, so for a couple of hours. And so that would be in the same category as typical batteries or long duration energy storage or even medium duration energy storage.
I think one thing that is important to recognize as well is that, like Google and other large energy users, they may come with their own power purchase agreements, which they're using to bring additionality to the grid. So when they're bringing their new load, they're also bringing some supply to help mitigate the impacts to the wire infrastructure. But the data centers and other large electricity users are not themselves an island, and they can only be as clean as the grid that they are connected to. So I think when we're looking at how data centers can become more green and more sustainable, I think it's also looking at the wider grid infrastructure itself and thinking, well, actually, how can grids themselves become much more sustainable and more environmentally fitting? And I think by looking at what is necessary, going back again to some of the scenarios that we've been modeling, and some of these messages has also made it into some of the COP agreements over the last few years, is that to kind of move us on this transition to a clean energy system, particularly when we look at renewables, the IEA has done a lot of modeling, and we know that between now and the end of this decade, we'd need to triple the amount of renewable capacity that we have globally. Looking at how we can manage electricity on a 24/7 basis, we need to increase the amount of storage that we have so that we can absorb surplus renewables when they're generated and shift that load later on to when it's needed. And to achieve that, we need to increase the amount of battery storage on the grid and other means of storage by 6-fold between now and the end of this decade. But we also then have to look at the infrastructure itself. As data centers load is increasing, the load is also increasing for buildings. We're electrifying heating, we're having more heat pumps into buildings, we're electrifying transport, and all of that comes with its own load, and that needs increased grid capacity. And some more modeling that we've done is that between now and 2035, to stay on track again with the potential load increases that we're modeling, is that we need to increase or refurbish power grids around the world. And we need to do around 80 million kilometers of grid refurbishment or extensions. And to put that into context, that's roughly equivalent to the entire grid that exists today. So it shows you like the amount of change that's going to be necessary. But also one thing that has been touched on just in a couple of points here is energy efficiency. We need to see how also we can utilize energy efficiency to help mitigate some of that. I know we've seen the messaging that was agreed on at COP not last year, the year before, about the need to double energy efficiency improvements globally. And a lot of that can come from areas by utilizing the data centers as assets and looking how they've progressed so far. I think just kind of looking back historically in our analysis by looking at data center improvements, we can see that over the last decade, the amount of data that's been handled by data centers globally has increased 25-fold, but the amount of energy that is used to manage all that data processing has only increased by 2. So there's been huge efficiency gains in data centers. And whilst that curve is starting to slow down, ultimately, as competitive environments do, that'll create more competition and hopefully much more efficiency, more efficient chips going on forward. But I think another way to look at data centers as well, and this kind of wider conversation of systemic holistic viewing, is how to view data centers as assets themselves, not even for how they increase efficiency themselves of their own operations, but how they could be better integrated into the environment which they fit. And I think particularly when we look at the potential for waste heat, the majority of energy that's used for data centers is for cooling the computing. And that waste heat has got a lot of potential, particularly for reusing that into the decarbonization of heat around. It's already happening in certain areas. I know Google and others have already started by looking at some small pilot projects about harvesting some of that waste heat and transferring it back into district heating systems so that you can reduce the carbon emissions of the local environment. But that then comes back to how do policymakers fit into this picture, because the likes of Google and others can only provide that waste heat if there's already infrastructure there available. I don't think we could expect anyone to go out and build something in the public highway. So it's then the onus comes back to the policymakers and themselves and the city planners and administrations to say, how can we look at these rather than a risk of energy consumption, but as an asset for the future?
Artie, just to add to that, so I think one actor group that hasn't been mentioned there is the user. So we know, and this has been touched upon, that demand is outstripping the efficiency gains that are being made. Gartner recently reported that by 2027, 40% of AI data centers will suffer from operational limitations. That's going to be felt by the users of these services. So something which I think we also have to look to change is mindset of particularly corporations, which are ultimately only collections of people. Recognizing that we have a responsibility in how we engage with AI, and that actually we have some degree of control as a collective to taper back that demand to ensure and allow time for further efficiency gains to come into effect. I just wanted to flag that because I think that's an important actor group to keep in mind.
Thank you. Sarah, I think I can even see that there's a lot of questions online, so I'll turn it over to you to ask one.
Thank you, Artie. We do. So I'm going to start with the first one. So Google's parent company, Alphabet, has invested in TerraPower. Sorry? Okay, I heard my name. Okay, Alphabet has invested in TerraPower and other companies developing small modular nuclear reactors, also called SMRs, marketing them as carbon-free energy solutions. While nuclear power produces minimal direct carbon emissions during operation, it presents complex sustainability challenges with regards to uranium as a finite resource, the mining process for nuclear fuel, and also the nuclear waste that requires secure storage for thousands of years. So how should we evaluate these new SMR technology given their potential for immediate carbon reduction and their long-term waste management, and when it ties into the energy mix to actually power the data centers?
Yeah, thank you for the question. And I think I need to correct because I don't think we are the ones investing in TerraPower. I think those are my colleagues at Amazon. But we have projects with SMRs, like the public one that we had last year was with Kairos. This was not an investment. This was what we called an order book. where basically we work with them to get a portfolio of projects lined up over the next few years to help them deploy faster and scale up their technologies. But that's the same spirit. That doesn't change, the nature of the question. And I do agree that I think there've been historical challenges with nuclear power along the value chain, along with also cost and execution. I think we need to, be candid about the fact that it hasn't been easy to build nuclear power plants in most of the regions more recently. And so there's really a real challenge there. It's an opportunity for us. SMRs are high power density assets, which is, necessary for data centers. Renewable energy as a limitation from that perspective is that you need a lot of acreage very quickly to get to gigawatts. And so I think nuclear is something that we cannot really ignore at this point, knowing the demand. However, we do see advanced nuclear as kind of a Gen 3 plus or Gen 4 generations, for those who are more familiar with those, as a real opportunity because they are presenting more safety solutions from like a passive design perspective. So not just, we can get into design considerations, but we do see a lot more safety first type of approach to designs, which are removing a lot of risk that we've seen in the past. And from the fuel perspective, also different types of fuels and fuel management and looking down at the value chain as well in terms of like recycling. So this is something that we're taking into account when we are engaging with specific technology providers. And we're looking at the external environmental perspective, but also in general, what it takes to build those systems. I don't know if I answered fully the questions, but wanted to highlight a little bit our approach in that space.
Any other
Sorry, I keep.
No worries. Any other thoughts, Tom, Ian, Brendan, on the topic of nuclear energy, maybe even more broadly on the topic of nuclear energy powering data centers and, as a low carbon solution, but with the other sustainability impacts?
I think it's looking at it as a wider suite of tools available. I think it's very noticeable the rise of nuclear again in the recent years that has become much more visible. Potentially, we can see there's new large contracts being awarded. Potentially, some semi-retired units in America are being brought back into service again, which again, from a sustainability point of view, is a good thing because the embedded carbon is already there within the facility as well. So it's good to see them being used. But again, looking forward, it's a difficult area, particularly when it comes to economics, cost overruns, and I think on a regional by region basis is going to make sense in some localities, whereas it may not make so much sense in others.
Regional energy sources for the electricity grid. But first, I'll give you a quick introduction. And if you have any opening thoughts on this question of the interconnection between data centers and the electric grid. Alexis Noman is the CEO and co-founder of Greenly, which is a European carbon accounting platform providing one-stop sustainability shopping. Greenly provides organizations with visibility into the carbon footprint of their operations, including their IT infrastructure based on a standardized methodology that also allows for intercomparisons between, say, different cloud service providers. So Alexi, if you have any opening thoughts to share with the group on the topic of data centers and the impact of on the electric grid, we'd love to have them.
Sure. And so thanks so much for allowing me to speak here. I'm sorry I had a slight delay for personal emergency, but all good. The reason I can talk to this topic a little bit, right, is today we're helping we're helping thousands of companies do their carbon accounting, but specifically in the services and tech sector, the majority of these companies' emissions in their scope 3, so their indirect emissions, tend to be digital emissions. And it's actually something which you can track pretty well. And so we have a operational understanding of why companies do it, how they do it, and what type of decisions they make based on the measurements that we provide to them. And I can just talk to our own organization. So we're a typical SaaS company. So about 50% of our emissions is our digital footprint. Half of that is our own consumption of data centers. And because we have to walk the talk, we ourselves decided to change cloud provider to reduce our own emissions. And so maybe just to explain a very simple thing and how it's computed. So we all know that the more electricity you consume, the more footprint you emit, and it's largely due to the carbon intensity of that electricity. So it just so happens that you can measure this very well for data centers. So the way we do it simply is we connect to our customers' cloud consumption services, API services. And this gives us a very, very granular depiction of their cloud consumption by instance level. So it's very well done. You get basically minute level consumption of each vCPU, each CPU. And actually, you can point those consumptions to which machines are used. The standard manufacturers of these machines will publish the minute level electricity consumption of these instances. So you can essentially tell for every instance what machine is being used, and based on that machine, how much electricity is consumed. It's a lot of lines, it's a lot of data, so you need a software to automate this. But you can have essentially real-time measurement of the electricity consumption of the cloud, and you know exactly where this electricity is consumed. And you can sync this electricity with also an hour level understanding of the carbon intensity of that electricity. So basically, to sum it up, most companies in Europe, at least, will have most of their cloud being used, let's say in Ireland, because Amazon is a dominant player, and that's where they'll have most of their cloud. And so the consumption of your cloud is linked to essentially the carbon intensity of the electricity in Ireland, and it changes during the day based on how much sun and wind you have. And we can compute this. Why have so much detail? Well, essentially, having an hourly view on things reduces the data uncertainty by up to 40%. You can do arbitrages. There's only two things you can do to reduce the the carbon footprint of your cloud is you can consume less electricity, or you can have less carbon intensive electricity. So consuming less electricity is possible because you have workload capacity. You can use certain instances that are more efficient, chips that consume less, basically. And so you can arbitrage between your different instances if you have the technical option to do it. And that can save up to 20% of your emissions. But it's subtle and you need to change the way you work. There's a simpler thing to do is you can just connect your data center to a source of electricity that is low carbon. And so here it gives some competitive advantage to essentially countries that have low carbon electricity. I think it's one of the arguments made by the president of France in recent days, that it's a good country to host data centers. So I'm not a VRP for France, but it is something that, of course, carbon is only one element of it, right? Companies do not change their cloud provider just for carbon purposes, but they will if it's at the same cost. And not to speak too long, but just tie it with why our customers do it. So it doesn't cost much more to essentially change where your data is located and reduce your footprint. We're a small SaaS platform, but banks, big service providers, that's major for them. it is an argument for them to change hyperscaler. So they do it. We work with companies like L'Oréal, like LVMH on these kind of topics. And I can't speak for them, but I do understand that they do take that into consideration when they do their arbitrage between different providers. It's specifically a European topic. I don't think US firms look at their hyperscalers in this way. And of course, there's not just the footprint of the electricity, there's the cost of it, but this is beyond our control. So, thank you.
Thank you so much, Alexi. I don't see any signs up here. Okay. Boris.
Sorry, I had to step out. So in case this wasn't covered, just wanted to touch on, I think the conversation around nuclear sometimes doesn't get put into perspective. So with all the hyperscalers announcements, they total around 8.5 gigawatts of nuclear. And a recent study said that AI is driving a new demand of natural gas of 46 gigawatts by 2030. So just to put these things into perspective, the way AI demands, the near 24/7 type of energy demand profile, it's leading a lot of folks to be using sometimes behind the meter gas turbines, which might not even show up in public repositories that folks rely on, like electricitymaps.com, which it's a great resource. But I just wanted to highlight that some of the kind of dynamics happening on the grid are leading folks to rely much more on fossil fuels.
Thank you. Sarah, is there a question online?
Yeah, actually, that's a good follow-up because this one is about renewable energy. Do you feel that the growing use of clean energy by data centers could lead to an increase in use of carbon-based energy for the other sectors of the economy?
Does anyone want to take this question?
I think we kind of slightly covered this earlier on, but as I said, data centers or any other consumer themselves will only be as green as the grid that they're connected to. So I think one of the important features is to focus on the grid itself and the investments into the grid, into the increased capacity infrastructure, that it can handle more renewables as well, because currently, in addition to this need to build out the grid to manage future load, this also is needed to manage future renewables. And currently there's thousands and thousands of renewables, of wind farms and of solar farms, which are unable to get connections to the grid due to misaligned planning. So what is really important is to look at a more integrated planning approach. I think a data center, you could build them in maybe 2-3 years. EV chargers, less than 6 months, you could get on the grid. Local distribution grid could take 10 years to build. Transmission infrastructure can take up to 20 years in some areas to get built. So the timelines are not working together. So it's important to focus on how that can be accelerated, how those lead times can be reduced, how permitting could be modernized, streamlined, to make sure that the investments and the infrastructure are there when they're needed.
Yeah, and I will add to that like a concept that is called additionality, in how, corporates and hyperscalers are looking for net new clean capacity. And I think that's important because, to your point, if you go in a certain market and you kind of like take on existing clean energy assets, you remove them, right, from existing users. And I think it's the reality. And from my perspective, having this additionality discussion, which is when you actually procure clean energy, where is it coming from? Can you really make sure that you are building those projects in addition to what is already existing on the grid? that's something that we've been trying to do a lot at Google, and other hyperscalers have also certain approaches to additionality. But I think it's something important for maybe local authorities and users to take into account when they look at hyperscalers or just generally new data center assets, is what is the portfolio of clean energy capacity that those assets are ready to bring along with them, or ready to invest into the grid where they are increasing their presence.
I think we have a question in the room. Okay.
You've been talking about grids as an asset, and about the grids byproducts, like injecting heat, using the cooling to create heat or energy. Is this something that you've already modelized, and is this something that you've already used?
Yeah, so I can cover part of it, and Brendan, maybe the IEEE has more consideration on modeling. So we have used it, and we've been user in the sense of like two things. One, heat recovery, or heat waste recovery. We have our first projects in Finland, in Hamina, which is where we have our data center. And so we've been able to work with the local infrastructure and stakeholders to actually re-inject or waste heat into the district heating infrastructure. And that would cover 80% of the annual needs from the local community, knowing that this is one of the sites where actually our electricity is clean also. And so that's kind of a low carbon heat from that perspective, because we have a 97% carbon-free energy in this region. So that's a nice way to look at the end-to-end view on that. And in terms of like grids as a user, the other aspect to that is us bringing flexibility as a user to the grid to help them better integrate renewable energy. And we talked a little bit about it. I think there's more work and research being done in that field, in being able to flex your compute loads. Gets back also to the user discussions on like, what are we ready to do in terms of trade-off as like end users? Are we ready to wait a little bit longer, or look at different locations so we can move and shift things? But also, what can we do as more microgrids on site? We're seeing emerging models around co-location or private wires in Europe. I think there's a lot of opportunities there as well.
So on the waste heat and the potential of data center energy efficiency policies, I think that yes, I obviously Google are already doing this. I would point to another interesting case study which does demonstrate how planning can be aligned to be more efficient and effective. Is in Ireland last year, there was a new district heating system that was initiated, and that was the first district heating system in Ireland. And that was done together with Amazon Web Services and the local city authority and the power system operator and a local university. And they all came together to say, we have a university here, we'd like to decarbonize it. You'd like to build a new data center. If you position it here, we can then make use of that waste heat. And that was planned from the very start. And it does show what is possible with a much more systemic approach. And on the second part of that question then on waste heat, on a wider part, we're currently working on a new report on energy and AI, which is going to be released in the second quarter of this year. So we had a global conference on AI back in our offices in the IEEE last December, just before the holidays, and that the conversations out of those meetings have very much informed this report, and there's quite a lot of much more additional quantification and research and analysis that's going into this report currently. And it will be featuring a lot more of these case studies, a lot more data. But in parallel, yesterday at the AI conference, the summit, our executive director, Fatih Birol, was on a panel, and he made an announcement as well, is that in parallel to the report of this energy for AI and AI for energy, looking at both perspectives, we're also going to be launching a global observatory on AI, where we're collecting case studies and data from all the potential uses, efficiencies, and anything related to AI going forward. So I think if anyone wants to feed into this from research organizations or think tanks, we'd be very much eager to receive some of those case studies coming into us so we could look and add those to the observatory.
First of all, any additional thoughts from Tom, Ian, or Alexi on this topic?
Yes, just a quick comment on that. The use case that we see around this is essentially customers and services like banks who have typically committed to, let's say an SBTI trajectory, science-based target initiative. So they have committed to say engage 2/3. They need to engage their suppliers up to 2/3 of their emissions. And in fact, when you look at their top 10 IT service providers, that's it. So if they want to comply with SBTI, usually they need to decarbonize their cloud. And so it's a very quick win for them, so to speak, to put pressure on these top providers. So I really believe, from obviously maybe anecdotal examples, but that hyperscalers have a strong pressure to decarbonize the energy that they are plugged onto as a result of a number of frameworks that push their biggest customers to reduce their own emissions. And so that's an effective way to essentially create virtuous circles on that front. So.
Sarah, was there another question online?
Yeah, sure. And I can combine two of them. One of them is, are you aware of any incidents in any country that reveal the real strains or even failure to the grid due to the powering of data centers? And then the second question that I would ask you, how do you think cities and local government can support the sustainable adoption of AI, considering the environmental implications affecting city energy? So is there any role at the local level actually for the management of electricity?
Anyone want to start?
On the first question, I have to say no. Other people might have, but nothing that I'm aware of. I think on the second question, like talking about local engagement, I think that's where it's important to actually have a real strategy on enforcing and incentivizing local clean energy procurement. And so that's why, for instance, we are advocating for things like granular certificates, granular guarantees of origins in Europe, so that people should actually know where you are procuring your geos from and from which countries, and really incentivize having those as close as possible to the load. And similarly, I think today there's like a misalignment of incentives, because we talked about SBTI and in general the greenhouse gas protocol. And if you look at how you do scope 2 market-based accounting, this is on a very large regional, continental level. And so today you can have a scope 2 that is very low carbon, scope 2 being mainly your electricity consumption, but you might have no renewable energy or carbon-free energy in the regions where you operate. And that's a limitation. There's a reform ongoing, and I think it's an opportunity to just be more specific and more transparent and more precise about what you do and how you do it. There's a whole spectrum. I think we need to also set expectations on what different entities and different users can do. But being more transparent about that should help customers make the proper decisions in terms of what they want to put the cursor on sustainability and other commitment from the supply chain.
If I can just add a quick remark. So Google Scope 2 is Google's customers Scope 3, right? Yeah. And so here there's an interesting point, because we've had this debate, or had to explain a lot with our customers how the electricity emission factor is computed, and it has a lot of influence on how you account for cloud emissions. I didn't go into that detail, but essentially, correct me if I'm wrong, but you take a location-based approach, right? So you look at the average mix of where your data centers are produced, and hence, and that's how we do it too at Google. But not every provider does it this way. So many take a market-based approach, saying, look, we bought all these renewable energy certificates. And so although our data centers are in a high carbon intensity place, we actually financed this or that. So there's the whole question of additionality, which is sometimes hard to prove. But as a result of this, if really the carbon footprint of cloud or AI is a deciding factor in procuring, in companies procuring a provider, it's, I believe, important to advocate for a common methodology. Because you're comparing apples and carrots here, where you have perhaps one hyperscaler saying, look, we're location-based, so it essentially gives them credit for being in a low-carbon country like the Nordics or France or so on. And if you're not in a low-carbon country, you're obviously advocating for a market-based emission factor. And so that's what you put in your reports. And it looks as though you are very good yourself, but really, in my view, it's more questionable. And it's a problem because you're essentially blurring the. I mean, you're not giving the consumers real choice because they don't have comparability on this topic. So, since we're in a policy-making body, I would advocate for pushing for more location-based emission factors in comparing scope 2 or, cloud or AI emission factors, because then it would push everybody to focus on cleaning the grid rather than perhaps having more market power to buy the whatever PPA is available out there, but without real additionality. And I say this with real conviction because I have had strong customer pushback of saying basically customers siding with some hyperscalers market-based evaluation, but essentially in an effort not to really decarbonize. So to me, it sounds very technical, but it is in fact an important policy move, I believe. And I don't think you'll contradict me because you're on location-based, but others might.
Yeah, thanks. I agree with you on the granularity and the need for standards, right? So we can all be evaluated against the things. The one nuance I would say is actually we're in between market and location-based, because if you do location-based, and so it's very deep right now, but I guess that's the purpose of the panel. If you do location-based, you kind of exclude a lot of tools for the hyperscalers to actually improve that emission factor. And so I think today the challenges with market-based is those are very broad, again, regional conditions with like no transparency on additionality criteria or whether you want just the certificates or you get the energy as well. But I think that's why on our side, we're actually looking at 24/7 is an approach for us that is kind of a mix between location and market-based, because we're accounting for purchases that we're doing on the grids where we operate. And for me, it's finding the right balance between accurate accounting, but also how do you empower or where can you give control basically to those users or those companies to improve and make progress. So that's where we come from, at least on 24/7.
Any other responses? Then I'll turn it over to Pierre.
Yeah, two quick methodology questions since we're at it. And I finally heard the word scope 3, so let's jump in it. And this is for the IEEE. And those are not gotcha questions, like genuine methodology questions for which I would like to have answers. Do you have a plan to extend your analysis to scope 3 energy consumption? That is, I agree that for now, the prospects regarding energy demand for data centers is pretty good. I mean, we can all agree that the efficiency gains are quite spectacular. But do we factor in the energy consumption of the construction of data centers, for instance, right? Or the energy consumption of manufacturing AI chips? So do you think that there is a chance we are underestimating the energy consumption of the AI sector because we're having a narrow view of the energy consumption?
If I may, actually, so we factor the construction of the model in our models, by about 20%, but we do rely on academic papers that says overall on the lifetime of a data center, the consumption is 80%, and so we weight, we give a pro rata weight of the construction of the data center on top of the consumption of electricity. But we do rely on models because we can't check, and information on the construction of data centers is hard to come by. If you compare, say, with the electric car industry, I mean, it's basically a data center is essentially an electric car without wheels. Cars are very specific and transparent on the carbon weight of their construction. So you know exactly with an electric car what's the weight of the construction and what's the weight of the driving. With data centers, it's harder to come by. There are academic papers on it, but I guess you are correct in saying you have to add a 20% weight of carbon, basically, as a rule, to estimate the full scope 3 linked to your AI or cloud consumption. But it's a model.
Just specifying, the question was really on energy demand, right? Like, and how much the energy demand of AI is actually not just the energy demand of data centers, but might have rebound outwards on other on the energy demand categories. I just want to know if it's negligible. Perhaps it's not a big, perhaps it's not an important factor, or if it's significant, but something we do not really measure.
So on this, it's a debate. And by the way, it's not well defined in the GHG protocol as to scope 3. When you report the usage of a product, when you report your footprint, there's not a clear standard as to how much of the usage of the product you have to report. So just to be super concrete, when you measure the footprint of, saying ChatGPT, most of the footprint is actually people using their phone to consult and charging them. So should you give OpenAI responsibility for the 10 minutes a day that I spend on my phone making a query and then charging it as a result? So it's the usage. So AI generates usage beyond its own consumption, if I understand your question correctly. And this is basically the GHG protocol says it's optional to report this. So you can debate all night if you want. But it is the
I can add on the couple of things on the more the upstream energy or indirect emissions, so like the scope 3 related things is, so I don't have an answer on the energy piece, but we have a beginning of an answer on the carbon piece. We've been doing some research for a while on what is the life cycle assessment, like LCA for TPUs, which are tensor processing units designed by Google, so the machines we use to run AI. And what we discovered is actually the bulk of the carbon emissions when you really look across scope 1, 2, and 3 for those machines. So how do you manufacture them, transport them, and then all the construction of the data centers around it. More than 70% of the carbon emissions are coming from the electricity consumption of those machines when they operate in a data center. So that was kind of a key takeaway for us, which is the bulk of those carbon emissions remains during their operational life and remains from where we source and how we source our electricity for the data centers. And that's a paper we published, I think, last week. So happy to share that resource.
So I'm going to ask a question that kind of pulls on some of the themes that I think have come out of some of the discussion we've had today. One of the reasons I think this topic is so interesting and important is that, one, we have kind of wandered into a world where environmental sustainability has come to mean only carbon emissions. And so, that has also led us to start to think about environmental impacts in these very big aggregate terms of, total carbon emissions. I think we know that that's not true. There are other types of environmental impacts that we need to take into account. And when you start to talk about data centers and the electric grid, you have to be hyper-local in how you're thinking about this, because there's real physics involved, and aggregating numbers doesn't really get to some of those impacts. So, I'm going to ask kind of a hard question, which is that, some of the discussions that we've had today include, well, one of the ways we can sort of take advantage or offset some of the electricity demands that come from increased demands from data centers is we can leverage the waste heat that's generated to decarbonize heat. But a lot of the places where, especially as we move toward the demand for sovereign data centers, sovereign AI, a lot of places where you may want to build data centers don't necessarily need a lot of heat. And those places may increase. The demand for heat generation is likely to decrease over time. On top of that, because of impacts of climate change, we're seeing other impacts on the grid. I live in California. In California, because of the drought, we've seen almost a 50% decrease in hydroelectric generation. And despite many policy incentives in California, we're adding capacity, renewable capacity, at like less than 1% of grid mix per year. And this is probably one of the states in the United States that put the most incentives in place. And so as much as we might want to decarbonize the grid while we increase electricity demands, there's these other challenges that we're going to face because of climate change. So I guess, given that we've talked about some of these solutions are, let's try to procure and accelerate renewable development. At the same time, there's just physical limitations to how quickly you can build a wind farm. And, let's leverage some of these other kind of auxiliary benefits like heat reuse. There's limited use for that. How do we think about this going forward? How do we think about putting a lens on, having a digitized future that also is one that's sustainable in many different ways? I'm going to start by asking Tom and Ian, because I think that's the lens that they put on their work, and then ask the rest of the panel to respond as well. Sorry, I put you on the spot to go first.
Thanks, Artie, for a very difficult question. I think from our point of view, what we've tried to really, I suppose, progress is that education piece. Because what we often find is that different actors within and across the digital ecosystem have very disparate levels of understanding and knowledge. Often the technical side of the narrative serves to confuse and make it difficult for many consumers to really have a grasp of the true picture, if such a thing exists. So in the work that we've done, we've tried to really nurture that awareness, not to provide necessarily clear-cut truths, because at the moment, given how opaque the data industry is, I don't know if truths even really exist, but to maybe bring into consumers' consciousness questions they might never have thought about asking before. And we're already starting to see more consumers pushing their providers for more accurate numbers, for more detail, for more information of what is actually occurring. And that's a really nice progression for us to see, in that it's taking some responsibility back to the consumer to say, okay, well, if we're doing X, Y, and Z, what is the consequence? What is the impact? Tom might have some additional thoughts on this.
Thanks, Ian. Just to follow on from what Ian's saying, we've been in a few conversations with the data center provider and the people using their services, and they've sat down and said, look, just tell us what our carbon footprint is. And they say, oh, it's very difficult to calculate because you share all the servers, et cetera, et cetera. So it goes back to it's very opaque, the whole data center and energy consumption, which causes a big issue, really. So if we can start to get more consumers to start to ask the questions, then hopefully we get better measurement systems and it becomes less opaque moving forward. And just on it came up the greenhouse gases, as you probably know, I'm a technical working group member of the greenhouse gases. We're looking at scope 3, and that's quite important. So this will be a new scope 3 coming out in 2 years' time. Can't say much more than that, but we're certainly looking at data centers and upstream and downstream of things that we do to see if we can start to measure in the future. But the bottom line is we need to agree on one standard that we can use across the globe, that we all agree on how to measure the energy consumption of data centers for the bits of work that we actually do via Netflix streaming, to storing data, to using AI to create the next ChatGPT model.
Well, I'll make a very small plug in a very different direction, but because you mentioned, it takes a few years to build a data centers, but it's much longer to build something else. Actually, no, it's not that long to build a solar farm. It's not that difficult to deploy, hundreds of megawatt hours of energy storage. I think to go in a very different directions, I think the issue is interconnection, permitting, all the, I'm going to say it, bureaucracy, years of bureaucracy that needs to happen to some extent. Rightfully so, because you have a level of due diligence that needs to happen. But I think today we're bogged down a lot by all those steps in the processes. In the US, it's like 4 or 5 years of interconnection queue before you can start ordering your solar panels, right? It's going to take you a few months to deploy this solar farm. In Europe, it's like permitting, so many agencies and so on. So for me, it's more, what can we do there to really cut through that red tape, being more thoughtful about how we deploy those clean energy technologies. We talked about advanced nuclear. We're very excited about it, but this is a 2030 plus horizon, right? It's not something that's going to solve our short-term issues. I do think there's a lot of readily available technologies. We just need to be better at deploying them faster.
Clara, and this will be our final question, I think, as well.
Thank you. I think that the OECD came up also with a report 2 years ago and on AI and climate, and one of the challenges was how to separate the compute of the data centers, so the general compute from the AI compute and consumption. And I was wondering if Alexis can tell us, is there a way, is a better way, since 2 years that we can actually make this distinction now?
Well, when we compute emissions in that respect, we don't know what is being computed. We just know how much is being computed, so how much vCPU, GPU is being used, and so we can infer from that the electricity consumption, but probably maybe it's training a model, maybe it's just queries or whatever. When we did focused studies on, say, what's the consumption of TikTok or YouTube or something like this, or even ChatGPT, what comes out is that 99% of the emissions, when you do a kind of life cycle assessment of a particular usage, is not the training, it's the usage. And so it's just us, consuming a video or consuming. So it's mostly the volume effect that drives, and correct me if I'm wrong, but drives the demand for data center. So it's not the smartest piece, if you like. But I guess you could tag. I mean, what's striking is how granular the data how granular it is, that data that's provided by the hyperscaler, because it's granular to help CTOs optimize their costing. But you can use that same data for computing carbon, and there are lots of tags. So where, when, which instance, and so on. So I guess you could add a usage tag, perhaps, but that's not my scope.
I'll jump in here because this is something that I've worked on. it's sort of to Alexi's point, it really comes down to the end user, meaning the company maybe that's leveraging these technologies, doing the work of workload tagging. And so you have to be able to tie the workload to whatever compute device is using that. And I would say that tools are a little bit cumbersome now, and it's not necessarily the practice of doing it. The benefits of it may not be so obvious to end users right now, so they don't necessarily do it. And again, it will depend on one, people putting those labels in, and then two, being willing to share that information, because that's the secondary challenge, I think, to that specific question. And also a critical challenge for the IEEE P7100 environmental impacts of AI working group. So this is a plug for all of you to come join us in trying to develop a usable and defensible standard in this area. So I think we're over time, but I will invite all the panelists, if you have any kind of closing remarks or thoughts on this topic. I think I could probably go on for another half hour here at least, but I think everybody would like to have coffee. But if you have any final thoughts to share on this topic or calls to action for future, discussions, the floor belongs to you all. All right, then. Well, thank you. Please thank our panelists, and thank you for a great discussion. And I think we have a coffee break now.
Yes, exactly. So we have a coffee break until 4:30, and then we are going to continue on the AI and water usage. So please come back. I think it's going to be an interesting discussion as well. So 4:30, we recommence. Thank you. Hello, everyone. Can you please take a seat? Thank you. So I think that we are now ready to move over to our last session. And I would like to give the floor to my colleague, Irene Kitsara, who is also working with me in Vienna and who, well, very much helped organizing this event. So on the last session, which is on the AI water usage. Irene, the floor is yours.
Thank you, and let me also thank the colleagues at the OECD for the excellent co-organization and all the support. So thank you everyone for staying to the last session of today's side event, which, as you heard earlier, it is also meant to feed into the work. The insights that we're gathering today are meant to feed into the work of the standardization work on metrics for environmental impact of AI. So we very much appreciate your contributions. We heard earlier about inference, we heard about emission calculations, about energy consumption, and the issue of water and in general use of resources has been less prominent in comparison, and it has been emerging more recently. We have been hearing also, similar to the deep learning breakthroughs in 2012, we have been having now an emergence in the number of data centers, with construction of data centers with LLMs and Gen AI. And so there are, with that came more public awareness and related societal concerns about the impact of data centers on water usage. We heard earlier from the indigenous world's representative the related concerns, and a lot of data centers are within. There has been a recent report. I mean, there have been a lot of reports that were published these days around the AI Action Summit, and one of them from Nature Finance is talking about the radius that nearly half of the world's data centers are built around close to 5 kilometers or less river basins. And of course, we know that a lot of populations are, their whole ecosystem is around that. We also have been seeing an increasing number of regulations, in particular in Europe, starting to mention related recommendations or obligations to start reporting on environmental impact of AI. And the word water starts emerging less prominently than, of course, carbon emissions or other energy efficiency or energy consumption. But still, this is an emerging trend that is worth noting. There are a lot of statistics around equivalence of volumes of water with countries, consumptions, etc., and they vary a lot. So just to mention from the same Nature Finance report, a statistic that only in the US data center consumed in 2023 66 billion liters of water, and 84% of that were corresponded to servicing hyperscale data centers. So we see the scale of that all. And we are very happy to welcome today 3 online panelists and 2 panelists on site. I will talk about them as we move forward in more detail. So online we do have Xiaolei Ren, Mashika Allgood, and Colin Heron. And next to me, I'm happy to have Jeremy Tamanini and Simon Gosset. So let us maybe set the scene a little bit and understand how does water relate with to AI. So let me start by asking Xiaolei about ways that water is used in the context of AI and how significant that usage is, in maybe to put it in context in comparison to other industries. Let me start by saying that Xiaolei Ren is an associate professor of electrical and computer engineering at the University of California, Riverside, and his research focuses on AI for good, including efficient AI and decision-making to address societal challenges such as public health and sustainability. Charlie, the floor is yours.
Sure, thank you. Thank you for the introduction. It's my great pleasure to be here. You may have heard that using large language model to answer like 10 to 50 queries can consume a lot of water, and might be wondering why. So I would just start with explaining how AI uses this water. So many of the AI models, especially those large generative ones like GPT or Llama, contain many billions of parameters for training and inference and run in massive data centers. So this process actually requires a huge amount of GPUs and servers. And when the servers are running, they will be consuming a lot of energy. And this energy will eventually producing huge amount of heat. And usually the heat doesn't go along with the servers. So you just have to remove the heat to the outside environment to prevent the system from overheating. And to do so, a massive cooling system is required to first transfer the heat from the servers to a heat exchanger, which is known as the server level cooling. And then we have to move the heat from the heat exchanger to the outside environment. And this process is known as facility level cooling. So the server level cooling doesn't really lose water, because it's just a closed loop, but the facility level cooling does. In many data centers, including those operated by major technology companies, water evaporation is often the primary or supplementary method for dissipating the heat from the facility to the outside. And just to give you some context, some of the technology companies can consume over 20 billion liters of water each year. And that amount of water is comparable or even larger than some of the annual water consumption of a top beverage company. And the huge water consumption is purely, not purely, but primarily driven by the expansion of AI services and workloads, just as acknowledged by some of the tech companies in their sustainability reports. So in some sense, this AI is turning a tech company into a beverage company. And according to the most recent Lawrence Berkeley National Lab report released last year, the US data center water consumption in 2028 will double or even quadruple the 2023 level, and reaching about 300 billion liters per year. So this is the direct water consumption. In addition, the AI computing also has indirect water consumption related to electricity usage. Just like the carbon emissions from the power generation, AI contributes to a large amount of water evaporation needed to cool the thermal power plants. So the combination of both on-site and off-site water reflects the true water cost of AI data centers. And some of the tech companies like Meta have started to report their indirect water consumption in their sustainability reports. So lastly, similar to the embodied carbon emission associated with the supply chain, AI also has embodied water. So basically, when we produce the AI chips, such as GPU cards, this process requires a huge amount of ultra-purified water to prevent contamination. So in some of the semiconductor fabrication facilities, they can use many millions of liters of water each day. But this part is often treated separately and not included in the calculation of operational water consumption. So broadly, all of the water consumption adds up to what we call water footprint. And it's very important to note that this water footprint has different colors like blue, green, and gray. And when we talk about AI water, it's mostly blue water that is often more scarce and refers to the fresh water from the lakes, rivers, or groundwater sources. And this water is directly usable for human. On the other hand, green water is the rainwater contained in the soil and used by plants. And gray water is the fresh water needed to dilute the pollutants. So this is not the water that we're talking about. And actually green water is the predominant water used by agriculture. Another thing I want to clarify is when we talk about water consumption, we're actually referring to the portion of the water that evaporates and isn't immediately available for reuse. So in contrast, when we take a shower, we use a lot of water, and this water is known as water withdrawal. So, but we don't really consume much of it because nearly all the water we use in showers will go straight into the sewage system and can be processed for reuse shortly afterwards. So it's really important to understand the difference between water consumption and water withdrawal. So with that, I would just pass on to the next speaker.
Thank you very much, Shaolei. And let me also inform the participants that Shaolei has a very informative article with a nice representation of the different uses of water on OECD's website. So that I found very helpful personally. Now let me turn to Simon. Simon Gosset is a director at Capgemini Invent, the strategy and transformation branch of Capgemini. He has supported many large companies in their data and AI transformation journey, and he focuses in leading the sustainable AI topics, focusing on AI environmental impact and the opportunities it brings to accelerate climate transition at corporate level. So we talked about the publication of several reports recently. One of the reports is a report that you have co-authored, a Capgemini research paper. What story do your figures tell about the AI water usage?
Thank you very much. Very glad to be there to contribute to this discussion. First, maybe getting to the figures, I'd like to share a few challenges from the corporate world to measure and to move forward on this topic of water consumption. 4 challenges. The first one, I think, is the level of granularity. We talked a lot about data centers or policy making. It's a good granularity, but in the corporate world, it's not relevant. What's relevant is the usage. You need to go deeper at use case level. And it brings a lot of complexity to go to that level. If we want the companies to be able to take good decisions in order to launch or not a use case, for instance, we need to be able to model the impact on the environment, including on water consumption. And to do so, you need a level of details that today are not accessible easily in the corporate world. You don't have the information to know if the impact will be good or not. It's really hard to do so. You don't have the skill set, and you don't have the material time, and you don't have always the incentives. So I think the granularity is really key to be very close to the usage, because this is where the decision is made. It's a small team, a software team, where you will have a data scientist, a business representative, a UX designer. On the future impact, it will be decided there. Should we take, what kind of model should we take? The decision will be done there. Do we want, in terms of user experience, to limit the usage? Again, the user, the designer will tell us about that. So I think it's really a difficulty to go deeper at this level. The second challenge I'd like to share is the focus on carbon, of course. I mean, the boardrooms are only focused on carbon today, and it leaves little room to other topics such as water. The new regulations such as CSRD for sure are helping, because now we have some ESRS dedicated to water, so it's helping. But again, the legislation is not at use case level; it's only at site level at best. So it's a discretionary effort from companies to move at a deeper level to do so. On the good news, we see that more and more companies are asking us to support them to be able to evaluate the footprint of their AI portfolio. So I think there is a positive trend on this, but it's very difficult to do it today with the current tools and methodologies that are available on the market. And this is the third challenge, that the current tools are not good enough regarding water. In fact, to be very pragmatic, when you want to assess the water footprint of a use case, AI use case, you use energy as a proxy today, because this is just the only way to do it very quickly and very easily. And we are going to release a paper soon on the benchmark of the different tools that are available regarding to assess the energy consumption of an AI model. And what are a key figure from this study is that the average error from these tools on the assessment is 500%. So energy is a good proxy because it's the only one available and documented, but on the other hand, it's already it's not such a good one because the current set of tools is not good enough, clearly. On why so, and that's my fourth point, it's because the way the AI industry is organized today is really opaque. And that's why we need more transparency for sure on the full value chain. And there is an ongoing discussion currently between the need for disclosure and the trade secret behind AI models. And our position is to say we could try to have both by agreeing on a few key metrics where we know that it's enough to have a right estimation without disclosing too much on the trade secrets. And this is we released a paper, and this is one of the key research questions we ask, and there is hope that we could try to balance both. Regarding the different figures from our study, just to give you a couple of figures on top of the well-known figure of half a liter per request on ChatGPT. Our study puts it more at 70 centiliters per request because taking into account the increase in the size of models since then, because it was based on GPT-3, I think, and the scaling laws and the trend makes that the models are always bigger than before. So 70 centiliters by one request. I think one other interesting result is there is an operational footprint on the embodied footprint. So embodied, so it's a GPU, CPU, production, extraction, etc. On operational, it's the usage in the data centers and the electricity consumption. And what's interesting is that for water, it's 30% embodied and 70% on the operational footprint. Whether on energy, it's 95 on the usage and only 5% on the embodied. So the embodied part for water is bigger than for energy, for sure. And this is an interesting view. Another one is the difference between the water impact between an LLM, large language model, compared to a classic algorithm, NLP, a few years ago. The difference is 5,000 more time between the two in terms of water usage. So it's huge. That's how fast the tech is moving, and that's the impact it has on water and the environment. And between a last figure, maybe, between a small language model and a large language model, you have a 20-fold difference between the two. So it advocates for clearly moving to small language model whenever we can. And we try to model it at a Fortune 500 company to say, okay, what's the footprint today? And it's the equivalent for a balanced portfolio of a 100 use case between mixing classic traditional AI approach and Gen AI approach, even agentic AI. And our result is that for such a portfolio, it's equivalent of 160,000 cubic meters every year. So 2 or 3 golf courses. And we try to project it to say, okay, and by 2030, what will it be? And our model says that it could be, if nothing is done on the current trends on usage pursue, it could be multiplied by 20. But our average scenario is more on 7, 8. Maybe to conclude, beyond those grim numbers, also we should not forget that, of course, AI is a very powerful tool to optimize. It can also have some interesting usage to make more water efficient, some industrial process, for instance. And we have a couple of, we have seen with clients a couple of interesting use cases to optimize the water networks using AI. So in terms of usage wasted water, you could reduce by 20% with such an approach, for instance, or crop flood prediction. So I think there are a lot of very interesting use cases regarding Earth observation using satellite data that we have seen with clients.
Thank you very much, Simon. And in order to pass from the grim numbers, which sound very alarming, we also heard, for example, yesterday at the French Forum for Sustainable AI, NVIDIA, for instance, talk about the efficiencies achieved in the terms of water usage, passing from one to the next generation of GPUs. I would like to turn now to Mashika and then to Colin and see how do latest developments in AI, what type of ways could they affect the expected impact on the usage of water in the AI lifecycle? And maybe let me start with Mashika. We heard earlier today the example about DeepSeek and the promises around efficiencies. So Mashika Allgood is an AI ethicist and the founder of All AI Consulting, a platform for providing AI education across different industries to people with non-tech and non-AI backgrounds. Mashika wrote the technical best practices product management section for the Foundation for Best Practices in Machine Learning. She's an active IEEE member and also a member of the P7100 Environment Impacts of AI Working Group. Mashika's first foray into AI ethics was as a founder and lead of the NVIDIA's first AI ethics work group to systematically address AI ethical concerns. Mashika, the floor is yours.
Thank you. And I'd like to actually speak a bit to put what's been said in context. I speak more for people who are working in government. And I'm an ethicist, so I speak for people, right? So I made a couple notes. Data centers compete with people for drinking water. The newest NVIDIA GPU is intended to run at 78 degrees Celsius, but can run up to 90 degrees before it starts to suffer performance issues. It's sold as a double server rack with 72 chips. Those racks require 4 liters of water per second to keep the chips operating within that 78 degree range. That's 240 liters of water per minute, 14,000 liters of water per hour, 345,000 liters of water per day for one 72-chip server rack. Countries are pledging to build data centers that house hundreds to thousands of these racks that will need to be cooled every minute of every day with the same water that you, your family, and your community use to drink, cook, and bathe every day. Data centers use drinking water to cool their servers because it's filtered. Sediments and water shorten the lifespan of the equipment, and we haven't developed filtering technology that would allow us to use ocean, reclaimed, or gray water for data center cooling at scale. And unlike when you, your family, or your community use water to drink, clean the dishes, or wash clothes, the water data centers use cannot be recycled. A full 60% of it is evaporated during the cooling process, which means it's no longer available for the community to use. And water replenishment, while a cool idea, is not being done at scale, so it isn't offsetting the losses communities are suffering in any significant way. That's the situation today. Currently, there's not enough drinkable water on the planet to support the amount of compute that companies and countries have pledged to develop. There may not be enough drinkable water in any given country to support the amount of compute that's already been built over the next 5 years. And while there are theories and ongoing trials and experiments of less water-intensive server cooling technologies, there is no technology that can be rolled out at scale in 2025 that will enable us to meet the forecasted demand. And given our rapidly drying Earth, there's not even a guarantee that less water-intensive server cooling technologies will significantly slow our march towards water scarcity. The math indicates that this is the exact wrong time to inflict a new hyper water-intensive technology on the Earth. It is incumbent upon each leader here to decide for each of your countries if you're willing to trade population for productivity. When the taps run dry, populations dry up as well. For those of you who choose population, I urge you to reject the trade-off that's being proposed to you. Generative AI is a form of AI, but it isn't the only form. You have the right and the responsibility to choose technology that aligns with your values and goals as a human and as a steward of your resources. You are not required to accept what the tech industry is offering you. You're the customer. If the product doesn't meet your requirements, send it back and demand that they do better. For those who choose productivity in the hopes that innovation will save us from the water crisis, I urge you to fight for transparency. No more flowery words, no more open-ended promises. Fight for here and now, time-constrained, factual assessments. What is the technology? How does it work? How fast can it scale? What factors need to be addressed in order for it to scale? What impact will it have this year, next year, over the next 5 years? And what could keep it from having that impact? We have to move beyond belief in what we're told. In tech, we have a saying, trust but verify. You need to be in a position to verify what you're being told by tech companies at a granular level. In order to do that, you need to understand the state of your own resources at a granular level. Are you currently monitoring the state of your aquifers, both their level and their health? Could you accurately forecast how much of a strain a new data center would place on your drinking water? Do you have the equipment to monitor the actual impact once the data center is built? Do you have the laws in place to require that level of transparency? Do you have the staffing in place to implement the monitoring? And do you have the organizational structure in place to ensure that the information gets to the right decision makers and that they have the power to make difficult decisions if necessary? We all have a role to play in ensuring that there's enough drinkable water on the planet to support future generations. I know no one here takes that responsibility lightly, and I'm really glad to be part of a discussion and moving forward on how to help you meet your responsibility while also achieving your technology goals. So that's my broad statement around how we need to, as representatives of our countries, consider the use of generative AI moving forward. As far as DeepSeek, I think there's a lot of confusion around what actually the technology saved us, right? So DeepSeek taught us that you don't have to use massive amounts of compute to get better training, right? But AI, generative AI, has two parts, training and inference. So there was great innovation on training. So the training part now costs less water, less energy, but there was a trade-off. So the innovation made training less intensive, but it made inference more intensive. And inference, the daily running of a model, has always been the more costly part of a generative AI model, right? Running it every day, people hitting it every day. Xiaolei's president or his research explained to us how intensive the training is. And if you do that millions of times a day, it's a significant problem. So the innovation of DeepSeek was to make training more efficient, but at the cost of inference. So we don't have a net gain from DeepSeek from an energy/water perspective. If anything, it's kind of worse for us because they took the most intensive part, resource intensive part, and made it more resource intensive. So we're not in a position where we're better off now because of DeepSeek. I think the goal or the charge is for someone to now innovate on inference. And if we could do for inference what DeepSeek did for training, then we might be in a situation where large language models are in some possible way compatible with the water that we actually have on the planet. Thank you for your time.
Thank you, Mashika, for bringing in the perspective of the end users, the consumers, and I think that also highlights the need for literacy around both the use, but also the appropriateness of use and also the environmental impact of each of our daily activities. You also referred to innovation and technology, and let me get back to that and ask Colin. So Colin Heron is the Senior Water Resources Management Specialist at the Global Water Partnership in Stockholm, Sweden, where he supports countries in improving their achievement of the water-related SDGs. In his 25-year career in water, he has worked in the Water Security Water Security Director for the Nature Conservancy in Mexico and North and Central America, as an advisor on water issues for the governments of Mexico and Turkey, and for international organizations, including the World Water Council, the World Bank, the World Meteorological Organization, and in the International Union for Conservation of Nature. So Colin, what would be some tools that we have through innovative approaches, either in cooling or other technologies, which can help us reduce the water usage in AI data centers or other parts of the AI life cycle, and how feasible are they to implement at scale?
Yes, thank you, Irene. And it's very difficult to follow Mashika, I have to say, but great points have already been made. But I also wanted to put my response into context and the interventions we've heard so far. As the water person in the room, I feel I have a moral or ethical obligation to speak up for water. And often water is the silent stakeholder in the room. But I have to say, as a water person in this room, I've actually learned a huge amount today. It's very refreshing to be among a different community. So thank you for the organizers for inviting us here. So I just wanted to clarify, first of all, that the water we have on Earth now is the same water we've had since the dawn of time. Of course, just now there's a lot more people and water use per person is growing exponentially, not just due to AI. Of course, AI is one factor, but we use water for everything. We use water for food. We use water for drinking water, of course. Industry also uses water. If we look at the different uses globally, about 70% of water is allocated for food production, for agriculture. So that is really the biggest opportunity for savings. About 20% is allocated for industry globally, and about 11% is actually drinking water. So yes, there is competition. Yes, there is a trade-off to be had. I have to say that often what has happened is that water has been over-allocated. So we're actually using more water than is sustainable for different uses. So that's a bit of a starting point. Of course, groundwater in particular is the go-to resource when we're overusing water, and that is unsustainable. So eventually, something has to give. So I just wanted to say that we have set as a global community a set of targets on Sustainable Development Goal 6 related to every single aspect of water use, and that should be our North Star for everything we do on, not just on water, but in general, everything we do on Earth. So we're not on track to meet any of those targets, unfortunately, right now by 2030. So now getting a little bit more to your question, Irene. So unfortunately, water consumption that hasn't had the same level of interest or attention as energy. So unfortunately, we don't tend to have very good data on water consumption in AI, actually not in other sectors either. So we're struggling a little bit with the baseline data. There are different estimations, of course, but they are exactly that, estimations. And I think we heard earlier today that if you can't measure it, you can't manage it. And most data centers, in fact, we find that they don't measure it, or at least they don't disclose their water consumption necessarily. There are issues around public perception, which are pretty important as well. We find that while the water use in data centers is perhaps not as large as other uses in reality, but in people's perception, often it is the biggest, target, should we say, the biggest culprit if there's a water scarcity issue. We heard a couple of years ago from Elon Musk when he was setting up a giga factory in Berlin, and he was asked if water scarcity was a concern for him. his answer, he laughed it off, saying, "Oh, there's no water problem here." And of course, his gigafactory was delayed by about 6 months, water scarcity being one of the concerns. So it's just not taken into account even often as a business prerogative. So there, now even more following the question, there are efficiencies that can be had, certainly in water use in AI, in data centers. I mean, that can be through siting, placing data centers in areas where naturally they would require less water for cooling. As an example, I actually did a chat GPT search before today to try to answer the question that Xiaolei very clearly gave some elements of answer to, which was how much water is used to answer this request. And because I'm based in Sweden, the answer was, well, probably it would be less for you because of natural coolness in data centers in Sweden than it would be for those of you who are based in France today, where nuclear energy is often the common power source, and that requires greater scope 2, I think, would be termed energy consumption, and for cooling for energy as well. So yes, there are efficiencies. There are examples actually in Marseille, in France, of where can I say Microsoft? Yes, I think I can say Microsoft without doing a publicity and promotion for them. But they've actually set up a data center in an abandoned coal mine, which has abundant flow of water as part of its sort of natural system. Not good quality water, not water that would be apt for human consumption, but water that is cool and can certainly keep data centers at a lower temperature, therefore reducing the need for additional water for cooling. So that's a good example of innovation. Innovation obviously is key to efficiency, but efficiency on its own is not going to get us out of this. The Jevons paradox was mentioned earlier, whereby if you're more efficient, you tend to use more of a natural resource. That also applies to water. So it's really a paradigm shift that we need in the way we view water and the way we do our business to consume less water in general, but also, of course, including AI. So I have more to say, but perhaps in interest of time, I'll leave it there. Irene, back to you.
Thanks a lot, Colin. And maybe Shirley would like to complement or provide some additional pieces of information around cooling techniques or other innovative approaches that can contribute to the reduction of water consumption and use in the AI lifecycle.
Sure. So I think currently the most commonly used cooling methods are cooling towers and outside air with water evaporation systems. So here, by the way, we're talking about the facility level cooling because inside the facilities, inside the data center rooms, the cooling is just a closed loop. Either you use air or you use immersion cooling or direct to chip cooling. There's no water loss unless there's a leak. But even though there's a leak, this is not water because this liquid is some special type of material. It's not just water. So for the outside part, these cooling towers, they are evaporating water 24/7, almost. And the water evaporation with assistance, water evaporation assistance with the outside air cooling, essentially you're just putting the outside air into the server room, but when the air is really hot, it's going to be evaporating water. So the cooling tower has a low average water, has a high average water consumption, but it's more steady. Although during the summertime it's elevated, but it's not that much higher than the average. On the other hand, this water evaporation systems is not using a lot of water on average, but during the summer peak time, it's going to be use a huge amount of water. So that's also the time when the other users are needing water most. So this, in terms of the water infrastructure, actually the second method, water evaporation assistance, will be putting more strain on the limited water capacity, limited water infrastructure capacities. So I think we should not just look at the total amount of water a year. Instead, we should look at both the total and also the peak demand. Similarly, how we plan for the energy grid. So we not only look at the overall energy consumption, but also we look at the peak power demand. There are some other type of cooling systems like so-called dry coolers that doesn't really use water on site. But this type of cooling system, which will be used by some of the tech companies, is actually increasing the energy consumption, which will also increase the indirect water consumption for generating the electricity and additional carbon emission. So there's if you see some claims like zero water consumption, that's really I think that's sort of a misleading message, because they're not really looking at the true water cost of the data centers. And these true water costs include both the direct and indirect. And if you use, let's say, if I don't use any on-site water, I'm saying I'm zero water. If I apply the same logic to carbon, then data centers are already zero carbon because they don't have any zero on-site carbon emission. Their carbon emission is just primarily coming from embodied supply chain and the electricity usage. There's almost zero carbon emission on site. So I think if we should apply the same standard as to how we account for carbon emission when we talk about water, and evaluate the overall water stress by considering both direct and indirect water consumption. So the best technology, I think, is really case by case. In some regions like Arizona, you might want to prioritize water consumption over the energy, overall water consumption over the energy. But in other places like Sweden, probably using water responsibly is not a bad thing, because it can lower your energy consumption and overall carbon emission. So I think this carbon, energy, and water, these are all complementary metric that we should look at as a holistic measure of sustainability.
Thank you very much. And as you referred to the different direct, indirect, and we have also scope 1, 2, 3. We should also consider the water usage and consumption across the life cycle when we talk about it. And speaking about metrics, we heard earlier from Simone that we're not at a satisfactory stage, and this is why I think the work of 7100, we hope that it can help create the transparency and the clarity around that. One question that I would have as a very short follow-up related to this metrics, which seem to be misleading and leading to greenwashing in some cases, to Simone, is around this balance to strike between this complexity, we heard it also in previous sessions, on one side, and on the other side, the need to provide clear or easy to digest information, either to consumers, policymakers, or investors. Would you have some thoughts about how to strike that balance, or what would be some considerations around that?
Thank you for the question. I think there are a couple of improvements that can be done for sure. So the first one is the need to have systematic multi-criteria approach to make sure that, I think it's the conclusion of Charlot's paper, depending on the situation, follow the sun, don't follow the sun, just between water and carbon, you see that it's not the same levels to optimize globally. So for sure, I think we need to make sure that the multi-criteria approach is implemented on not just the carbon. Another point is maybe regarding the proxy on the different models we can use to enlighten the decision making, because
I think this is the key point to make sure that the relevant decisions are made very early. We cannot just have ex post assumption estimation. We really need to put it in the hand of the business that will decide to deploy this model or this model. And today, some framework, some methodology exists, but they are really hard to apply to the AI industry on looping back to the issue of disclosure. So I think this is the best way forward today.
Thank you, Simon. And talking about optimization, there are a lot of business decisions around the location of data centers, which have similarly implications on water consumption. So we see, for example, data centers are often used in Latin America or Sub-Saharan Africa, in places which already face a scarcity of fresh water, so the blue water we heard earlier. We already see, even in Europe or in the US, incidents where local communities, and we heard also the other example, there was in Guardian an article a month ago about data centers in Oxfordshire, so not a developing country, what would one directly have in mind, but this is an issue everywhere. So this creates new water diplomacy and water justice issues, and ensuring that the opportunities for economic development on one side are materializing, but also that does not happen at the cost of access to drinking water, for example, for agricultural use. How can the AI industry collaborate with local communities and governments to ensure that the AI deployment doesn't really exacerbate this regional water challenges? And for that, I will turn to Jeremy, who patiently waited until now. So Jeremy Tamanini leads at Dual Citizen Inc. global sustainability projects in collaboration with public, private sector, academic and intergovernmental partners. Through his US-based practice, he created the Global Green Economy Index, a leading measure of country-level sustainability performance, and he also supports partners in AI systems integration with a focus on optimizing efficiency gains while limiting and measuring their energy and resource impacts.
Thank you so much. It's a pleasure to be here. I do focus on measurement. So I guess before answering your question, I wanted to speak a little bit about the measurement dimension of this. I think I'm becoming more and more of a traditionalist as I work longer in this space. And the reason for that is what's been touched upon before. I mean, I think that we have frameworks already to build upon around this issue. For example, right now, the issue of Scope 3 reporting is facing a lot of, let's say, pausing or contemplation or delaying, not just in the United States, but also in Europe. The issue of Scope 3 reporting is very important these are the indirect emissions that are outside of your purchased electricity, et cetera. It's very important for the water discussion. The reason being that even though water itself, in terms of like volumes of water consumed, is not as addressed yet as directly in the greenhouse gas protocol, there is guidance in the greenhouse gas protocol for the electricity that is used for the pumping, the treating, and the distributing of water in these data centers. So my point is that we need to continue to push for Scope 3 accountability and reporting among enterprises and other organizations so that we can continue to increase transparency and information for all of us around what specifically some of these impacts are around water, electricity use, and obviously emissions more broadly. And I'm concerned because, as Simon said and others, like I have many friends and colleagues who work in the corporate sustainability departments, and they're just overwhelmed by standards and new reporting requirements. So the last thing we want to do with this particular topic is to add on to that new standards and new complexity. We need to, I think, build and enrich on what's already there. But these particular existing standards are facing delays through the SEC, through the CSRD. So I think we need to continue to push there. And then I think, if we look back, I mean, the last time I was at the OECD was actually 10 years ago, which happened to be the Paris Climate Agreement, which was positive in many ways around measurement and reporting, not only for what it established on sort of a macro level around targets, but for what it led to on a subnational level and on a more grassroots level in terms of measurement and accountability. So for example, the Science-Based Targets Initiative we have, and I would argue as a result of the Paris Climate Agreement, a lot of the industry targets that have been put together in the finance sector or different sectors are a result of the high-level targets that were set through the Paris Climate Agreement. So I guess what my point here is that on this particular topic, there's a lot of importance of the bottom-up approach as well. So yes, hopefully, we will see progress on the Scope 3 reporting on kind of the high level, but I think establishing industry associations, establishing standards on the grassroots can be another way to kind of filter up into the discourse. So I want to just answer the question a little bit around how infrastructure itself can be impacted by a lot of these new tools. So the title here is The Hidden Costs of AI, and obviously a lot of these hidden costs have to do with the energy and the water impacts. But I actually see, in many cases with clients, the hidden costs are actually not pursuing some sort of AI integration around their infrastructure, business operations. We talk a lot about ChatGPT and these large models, which are hugely intensive around energy and water use, but actually a lot of models aren't as intensive. They're very specific, they're very targeted to particular tasks and can improve efficiency enormously around resource use, using these applications to improve the efficiency of water use within an enterprise, within a factory, within a building that you own. So I think it's important to sort of see both sides of the coin around this hidden cost. There is a cost at this point of kind of not looking at this. If you're a large company, I mean, I could go through many examples of how using AI can improve your water use, for example. And to the question, I mean, this is where policymakers can be particularly useful in intervening policy-wise with incentives that just promote efficiency, that give incentives even to SMEs to incorporate some of these new tools to promote greater efficiencies, be it water or energy use.
Sorry.
Sorry.
Thank you.
Yes. So I was saying that on one side we have the compliance requirements, and there has been, we heard earlier from Simone, one of the examples of European regulation and requirements for reporting, and in that sense, there has been also a related criticism that these are not really a lot are at voluntary level, and so there were a little bit more expectations about that, but such as, for example, for the AI Act. But at the same time, what could be some other thoughts on other type of incentives beyond what Jeremy mentioned? Mashika, would you have some thoughts on that? Where we could, the water efficiency could be encouraged through incentives. So thinking about the stick and the carrot, that there could be some positive expectations or incentives from the industry.
So I think the way that we've been approaching water, I appreciate this group and I appreciate the work that's being done on an international level. But I think water is a hyper local issue, right? It's a hyper local resource. It's a hyper local issue. And so when I think of how we can work with governments around water uses for AI, I think it really comes down to, there are already processes at the local level to measure or to hold people accountable for certain kinds of usage. So in California, we have these environmental impact reports. Like we passed a state law. If you're getting a zoning variance or if you're, asking for a water permit, you have to provide certain information about what consumption, what withdrawal, things of that nature. And I think everyone may not have, the California specific laws, but every government has some way to permit / zone for uses within their territory. And I think you take advantage of that process to require more information. So like what we're pushing for in California is just basic plain language, right? How much do you forecast that you will withdraw? How much do you forecast of that will be consumed? And then we can go back later and see how close or how far you were. And I think the incentive would be if you use less than you said, you get whatever incentive, tax incentive, something of that nature. But if you use more, then you may, face some sort of non-incentive, right? I think that we try very hard to make things on an international level, trickle down. And while that is laudable and it pushes both ways, I think the situation with water doesn't have the same kind of time. We speak often about how we're running out of time to work on carbon. And we've been talking about that for 20 years, but the earth has been gracious to us. But even now she's showing strain, right? So we can see we're running out of time, but it's more amorphous in a way. The weather is this, and these people are experiencing significant catastrophic impacts. But if it's not you personally, you can push it to the side. Water doesn't allow that kind of separation. If your aquifer runs dry, you can't drink water. So you saw in Mexico City, I believe it was last year, they had a date for when their aquifer was going to run dry, and they measured and they took actions in order to keep it from doing that. South Africa had the same thing, I believe, in the 90s, where they knew that there was a date, right? So I think it's incumbent upon local leaders or people within government to work with their local leaders to start understanding the situation that they're in. And then you can, when you have these permitting process, when you have these zoning process, you can ask specific questions. How much are you going to withdraw, forecast, for how long? And then how much of that, is evaporated? And then you'll actually have an understanding of, can we support this? So I think we often spend a lot of our efforts trying to work with the companies and what works for them and how they can report. But at the end of the day, they are encroaching upon a sovereign territory and their land and their rules. So I think the focus needs to shift to some degree to helping at the local level leaders understand what kinds of questions can be asked. And honestly, if the industry can't give answers, that's a problem in of itself, right? So I think we just assume that we have to like move forward at the pace that industry and the science allows. And I think that's an inversion of priorities. I think we have to move forward at the pace that is sustainable for the societies that you're moving into, because we can't say that the efficiencies that we're gaining, we don't honestly know if it is more if it's more beneficial in the end that I used an AI system to, make me use less water, because we don't know how much water that AI system costs. Like, we're not in a position to do that math. So we're often talking about, well, the AI can help you be better. Our climate AI can help you, do better about climate. But then we're not looking at, well, how much does that climate AI cost? That math does not yet exist. I've asked all the people who are in that arena, who are doing the Hugging Face and whatnot. Those more complex algorithms have not been mapped in terms of energy and water use. So I would hesitate to focus, very heavily on what industry can do to work with governments. I would focus more on what governments can do to push industry, because at the end of the day, you're responsible for the livelihood of your citizens and of the people who live within your territory. And so I think your voice should matter more than the people who are trying to sell you a product.
Thank you, Mashika. And Colin, considering your experience with water policy, what would be some thoughts on that?
Yeah, thanks. Unfortunately, our water policy globally is typically not up to speed already. Most of our water policies around the world, date from middle, maybe end of the 20th century. And, some of the more recent, of course, refer to climate change as something that's real and something that's actually happening. But many don't, unfortunately. So I would say we're not necessarily well equipped at the policy level to deal with the water use in AI. In fact, I chair a UN water task force on innovation, and we've been looking for innovative examples of public policy to support water innovation. We've not found many, I have to say. This is with the whole depth and breadth of the UN system. So I have to say there are good examples out there. The Corporate Sustainability Reporting Directive, which was mentioned, will force companies to disclose environmental impact and water footprints as well, if it's not watered down by the EU. Within the EU context, of course, and please take note that this is a Brit saying how great the EU is, not common to hear that. But of course, not every region of the world has the benefit of an EU. But I did want to mention that there is a voluntary mechanism that's being used by a lot of companies. It's a commitment through the Water Resilience Coalition to having a net positive water impact. And interestingly, the companies that have signed up to that have been mostly the companies whose water consumption is very visible. So I think there's a social license to operate, which is probably one of the drivers for those companies. So while it's voluntary, it's very much driving companies to put back the volume of water that they can't compensate for. They can't be efficient for, they can't reduce their consumption to zero, so that there's a volume that's consumed, as Xiaolei has mentioned. That volume can be compensated for with projects in the watersheds in which the companies are based. That's something that I think we should encourage. I think Mashika mentioned it at the beginning. Water replenishment as a concept exists. It's great, but it's not being done at the scale that we need. We have, maybe 20, 30 companies, leading companies that have really taken that on. Meta and Microsoft are two of them that have a particular sort of relevance for this topic. But it's just a small number of companies, and we really need to scale that up and to make sure that it's being well monitored and well implemented, of course, but also that it can really align the private investments in the good of the watershed with the public interests, meeting this public and private sort of divide that somehow seems to be preventing us from advancing in a coordinated manner. So thanks. Those were my thoughts on the topic.
Thank you, Colin. And let me now open the floor for comments and or questions. I see Arti.
Thank you. So I have a question that maybe it's two related questions that I'm just curious. I think one topic that often comes up. I work with some, water technology innovation accelerators in California. And one of the challenges is that we talk about water is very underpriced. At least in the United States it is. So we don't pay anywhere near the cost for water as a utility. So that sort of decreases the incentive to do anything about it. There a lot of companies have made commitments for greenhouse gas and renewable energy, but some of that also comes from electricity is becoming increasingly expensive. So there's sort of these other benefits to entering into PPAs and things like that, whereas the costs of water are often hidden. So I'm kind of curious how that plays into it. And then sort of related question is that on top of that, I think, from a scientific perspective, water is very complicated because you can't simply say this is the amount of water I'm using, because it could be that you're contaminating water. There's different degrees of contamination and usability. There's very complicated questions like exactly how much water is being evaporated through your cooling tower, which is dependent on atmospheric physics and a number of other things. So there's a lot of open scientific questions. At the same time, water is deeply personal, I think, for a lot of people. And so it almost makes it harder to come up with these very quantitative metrics to start to understand, to build a metric to say, this is my water impact. And so I'm just curious how this very complex thing where we both undervalue and deeply value water as a society plays into the difficulty of really understanding the impact of something like AI, which we sort of know without having all the numbers is definitely consuming water at an increasing rate.
Thank you very much, Artie. And let us maybe start with Charlie, followed by Colin. And then Mashika.
I think we price water at a very low level under the assumption that water is always available. But actually, water can be interrupted. Water supply can be disrupted. Even in the US, I think last October, there was over 40 states were experiencing some sort of droughts. So if this water supply cannot be taken for granted. If you factor into the risk of water interruptions, actually water is very expensive. So think about the water as a slow earthquake. So how much are we paying for earthquake preparedness? Earthquake doesn't really happen every day, but we're paying a huge amount of money for this potential risk in California. I know one tech company, they are building a data center in India. Due to the lack of constant water supply, they have to use alternative cooling methods that actually increase their cooling energy by over 25%. And that means their energy bill will be increased by 25% just due to the lack of water. So I think when water is available, yes, it's cheap. But when water is not available, that can be super expensive. So we need to really factor in the risk of water interruptions when we look at the price.
Yes, the uncertainty that comes in again. Colin?
Yeah, thanks. I think it's a really, really good question. And I think one of the biggest challenges we face is the difference between the cost of water that we pay, the price, and its value, which goes much beyond purely economic terms. And in fact, there was a high-level panel on water a few years ago at the head of state level, which came up with the finding that probably the biggest challenge we face in achieving any of our sustainability goals is that we don't value water appropriately, and we tend to put it in purely economic terms, which is really doing it a disservice. So there have been efforts to sort of shadow price water within companies to sort of evaluate what the real cost of the water would be in both economic and non-economic terms. But that's something that I think is picking up quite a bit of speed, because I think a lot of companies are realizing that the amount they pay for water is not really a driver for efficiency. But I just wanted to sort of say that the one of the biggest challenges is actually the subsidies that are applied to water consumption. So when one thinks of the water that one pays in the bill, often that's only a fraction of the real cost, and somebody's paying that bill. Often it's the government through subsidies, which are not necessarily well directed, and actually redirecting those to reflect the real cost of the water, be it in economic or non-economic terms, would be a very good way of driving efficiency. And a final comment is that it's often put forward as a trade-off between what is the human right to water and sanitation. It's a human right, so it has to be free, versus the real cost of water. The human right to water and sanitation does not say that it has to be free. It says it has to be affordable, which is a really key concept. So companies can pay for water appropriately. I think it needs political will from governments to make sure that the payment is actually reflective of the added value that the company is giving to the water, especially when it's in data centers, which are essentially a luxury commodity, I would say, still in 2025. Thanks.
Thank you, Colin. Mushika?
Yeah, I agree with what both of my colleagues have said. I think I wanted to focus a bit on the measurement question, because I think those of us who spend a lot of time in water, spend a lot of time talking to scientists and engineers, we get into the nitty-gritty details of mathing water use. But the fact is, every single company has the ability to say their withdrawals and their consumption over the course of a year. And you see that because they're starting to add it to their yearly ESG or environmental responsibility statements. So we have the technology to meter water. We have the technology to meter how much is coming in and how much is going out, and that loss is a thing. I think when we're looking at a policy level, the accuracy doesn't have to be 99.99%, right? Like I need to be able to tell the people, the local leaders, based on the size of my data center and the amount or the electricity draw, this is how much I forecast will be the water usage. And I have other data centers that are similarly sized, similarly composed, and this was an average of their water usage. Like I think, trying to get down to the scientific level is admittedly very difficult, but I don't think that's necessary for policymaking. So I think we can step back when we're trying to figure out, is this the right use within this region, and look at a more, what they used to call it, CEO math, right? Look at a more a little looser forecasting, because at the end of the day, what you're trying to do is give decision makers the information they need to make a decision, and they don't necessarily need the absolute scientific, accuracy to make a decision. They need directional information. So if you can forecast towards greater accuracy as opposed to less, I think that may suit their decision-making processes.
Yes, Simon.
Just maybe very quickly to comment on that. I think there is a parallel with what's happening on the carbon world with the restatements on the methodology. On you set targets such as SBTI, and then you end up reviewing it a lot because you change your methodology, you realize that your data was wrong. So is it an issue? I have this question from clients. So how do we get clarity on this? How do we get path on? At the end of the day, it's even if we know that the measurement will be the accuracy is an issue. The goal, I think, is to slowly improve it, whether we're not completely close to the science, but I think it's the same parallel that what's happening with carbon on the different restatement, making sure that we are slowly but regularly going further at a good level of details.
So starting with the baselines. Vincent?
Vincent from Google. I want to comment the fact about why we use water in some cooling. It's because it has generally a better energy efficiency. So you have a trade-off between so-called WE and PUE. It's about saving energy. So it's not using water just for using water. And if you go to generally at hyperscalers, if you run on water, you can achieve 1.10 PUE, somewhat. If you are on waterless, in the best case, you are 1.2. So that's the 10% difference on energy consumption. And then if your energy upstream is on coal, a very old coal plant will consume dozen liter of water per kilowatt hour. So in fact, end to end, it's better to consume water on site because it has a better water efficiency than the coal plant. So obviously, it's better if the upstream is not using water, but you have all those trade-offs. Another comment is about water is a very hyperlocal resource, it has been said, but also you have the scarcity that you have to consider into account. For example, we have data center in Belgium and Netherlands. They use non-potable water canal water. So we have our own water treatment unit, input, output. So everything is measured, obviously, because you need that for environmental permits. We have one data center in Finland which use seawater. We have another one in US which is using output of municipality water treatment units. We still consume potable water because we had data center which was built 10, 15 years ago, and this concern was not as high as it is today. But we have made a decision that for every new construction, we made a full water basin analysis using ACDUC, Atlas, WRI data, and above a certain threshold, we will decide to not add stress over stress. So we will take the point of we will consume more electricity in this case in order to save water, because in this location you have higher water stress. And also on top of that, it was mentioned, we have a program for water replenishment, which is a quite complex topic, how to measure the effectiveness of those programs. So we are participating to initiative about methodology of these kind of things. We announced a program for 2030 to replenish our global water consumption. We started in 2021 and we are now at something like 10-15% of the goal. And we prioritize a region where there are the highest water stress. We don't go through financial market and so on. We make direct selection, we make direct financing to local NGOs, municipalities, kind of things like leakage prevention or irrigation optimization or these kind of things that then you can have put in place methodology to say, okay, that correspond to this amount of saved or avoided or depending. And those kind of programs have also collateral benefits like biodiversity restoration. So sometimes vegetation or these kind of things. So multidimensional problem, and we are trying to do things to limit and to mitigate impact on this matter.
Thank you. So business decisions are come again as a trade-offs. I see Jeff, and then I see Sarah.
Yeah, just want to say thank you. This has been probably the most in-depth conversation on AI and water that I've heard. So this is really great. Vincent mentioned a bit on the trade-offs. Could some of the speakers talk a bit more, maybe specifically on kind of the carbon and water trade-off? I think I know with like region selection, choosing a sunny region with a lot of renewables is sometimes a more arid region. So are there any notable ones that folks should be aware of? Thanks.
Well, I'm not an expert at this. I mean, I heard Justin Trudeau saying on Monday that Canada would be the ideal location for data center development. No other thing was mentioned other than the cooler climate. So I do think that climate in terms of temperature has been mainstreamed into the discussion. Just in general, it's interesting how, compute has had this footprint for forever. I've been using compute for a decade. I've never thought about the environmental impact until this AI piece got married to it. So I think those two examples show how at least the environmental considerations have really reached the mainstream. Beyond location, I don't really know other good examples, so I'll pass to my colleagues.
I see. Did I see correctly? Colin raising his hand.
Yes, I was actually going to answer the previous question from Vincent, but I can also reflect on this one briefly. Yeah, I just wanted to say that in terms of water replenishment, and I should have mentioned Google earlier as well when mentioning some of the leading companies. Apologies for that. But unlike carbon, water offsetting is really local. So, a unit of carbon anywhere in the world, it can be easily compensated for. Of course, there are methodological questions that are also very important, but water offsetting needs to be done in a locally relevant way. Makes it very difficult to scale up a standard approach across all watersheds, where in some cases it might be an issue of water quality. In some cases, it might be groundwater or surface water that the challenge that's being faced. So this hyper-local approach really requires that companies can align their strategies with the local government priorities, and that's not easy. The one thought I wanted to leave this roundtable with is that there's a need for connectors between the public and the private sector. Without those connectors, I find that it's almost like a blind date where nobody's actually getting the two parties to talk to each other. We need them to talk, and we need them to talk quick, because 2030 is just around the corner. So that was one reflection. And on the second point around from Jeff, I think it was around trade-offs. The ideal place would obviously be where water is. I mean, renewables are in high quantity and cooling requirements are lower. So I would definitely say that Canada would be a very good option in that respect. I would agree with Justin Trudeau. It's not often I say that, but also Sweden and the Nordic countries actually would be very well positioned as well in that respect. But again, it just needs to be factored in that there is a trade-off, and often that very comment has been almost heresy in the past. Thanks.
Thank you, Colin. And let's now, sorry, Pashika, very shortly, because we have 1, 2, 3 questions.
I just wanted to briefly say we talk a lot about location, but I was actually watching a panel that Chalet was on where he kind of made it very clear that you can't have all the data centers in the world in Sweden and Canada, right? Like you have to have the data centers located closer to the people who are using them. So there is some degree of benefit we can get by locating data centers in places that have these really ideal conditions. But at the end of the day, if you're really trying to build a global system, you're going to have to build in a lot of places that don't have that particular mix.
Thank you, Mashika. And I think we heard the previous days discussions also around distributed edge computing as a potential of easing, this creating more balance across geographies. Jeff?
Hi again, Jeff Ward from Anemic Indigenous Technology. Traveled here from Canada. Colin mentioned water is often the silent stakeholder in the room. So Colin, I just want to thank you for centering water and bringing that into the space, because in my culture, water has life, it has a spirit, and we see water as a relative. So as to think about water as a stakeholder, or perhaps even a rights holder in this context, is very, very important. Mashika also asked this group, are you willing to trade people or population and productivity, which I thought was super powerful statement when we think about people and the trade-offs of technology. We also heard about data centers in South America, where indigenous lands and people who suffer drought maybe are not prioritized, and there's trade-offs. But guess what gets prioritized? Is it the people or is it the data centers? Thank you for mentioning Canada and the call for data centers there. As Indigenous peoples in Canada, through colonization, data, AI needs data, and data needs the land. So for us, it's many of us think of it as further data colonialism. And I think that's an important distinction to make. But my comments earlier were that Indigenous peoples have always been successful stewards of the world's biodiversity, the original land and water protectors, which takes Indigenous innovation and technology and a hyper-local perspective, right? These practices have ensured sustainability for generations. So if water is a hyper-local issue, and if Indigenous peoples are the best groups to take care of their lands and stewardship over the waters, then I'd encourage everybody here who is developing policy with regards to AI to center Indigenous voices. Thank you again for the opportunity to speak.
Thank you, Jeff. And I believe Sarah had a question from the audience.
Thank you so much. And thanks again for this great conversation. I agree with Boris. I think this is the most in-depth conversation we've had about AI and water. So I work with the Carnegie Endowment in DC, where we do a lot of work on AI in the global south and the global majority. And we're just building out some work on AI and water use. So one thing that folks have brought up today, and I really appreciate Colin and Mashika and of course Dr. Ren's comments. One thing that's brought up is the role of local decision makers in informing where and how data centers should be built and what is the limits on the land and the natural resources. And to your point, Jeff, I think it's a brilliant one, and we worked with Indigenous communities in our work as well, and welcome opportunities to engage. But across the global south and in advanced economies as well, it's been local actors who've been the fulcrum of change to drive for more transparency, whether it's in Chile or Uruguay or even in Virginia. I'm wondering if there are formalized channels to kind of engage with this collective community intelligence to build more resilient and more water and resource protecting designs for data centers. Is that a possible pathway to bring in, not just the private sector, but local elected representatives and communities as well? And secondly, it's a call for anyone who's, thinking, writing about this. We're actively looking for partners, not just thought partners, but also in policy dialogue as well. So I'd love to reach out to you, engage. Thank you.
Sarah? Maybe what I will do is there are a couple of questions online, so I will just aggregate them together and the panelists can decide which one I want to address. And there's also one raised hand online, so maybe we can also hear from that person. So one of the questions that was asked, and by the way, I just want to say that today we currently have 50 people online still, I just want to say, and we had in between 60 and 80 people who joined us. So I think this is a very relevant topic, and especially like having 50 people still online at 6 p.m. I think it's a testament that water usage is of interest to a lot of people. So thank you for the discussion today. So the first question is, how can we attract investors to do sustainable AI for water? And then the second is, not all government give out the choice to people to choose about the establishment of a new data center close to a community. So this is what Mashika brought up. And also what Charlie, I guess you also it should be located close to the people who are using that data centers, who has a word to say into that decision. And then the question is, what can be done from a civil society perspective? And then the last question is, how does the concept of fair water footprint sharing relate to the hidden water and energy cost of AI? And what ethical responsibilities do tech companies and consumers have in ensuring AI development does not exacerbate global water scarcity and inequality? So I'm going to put them, the three out there, and then maybe we can pass it. Oh, I saw that Catherine had her hands raised. So I'm not sure if Catherine can be unmuted and ask her question as well.
Hi, it wasn't really a question. I'm grateful to be able to participate today. So my name is Catherine Foster. I'm with the EIT Food, but previously with the Green Digital Finance Alliance, and a former Canadian diplomat on climate and environmental issues back in the 90s and 2000s. And I just wanted to make a few comments here because I've also been a specialist in carbon. And I think that some of the points that really resonated were, one, that the hyperlocal but interconnected element. So linking cross-border supply chains, whether those are within nations or across regions, food production and energy grids, and demanding sort of the demand for integrated governance and holistic management. We've seen that, the pros and cons of that, of course, in carbon. The proposal, I'm so grateful for the intervention on Canada, because I think that proposal, while we do have cold climate, we also have very extreme summers as well. And it fails to address, those extreme temperature fluctuations, as well as pollution and existing water tensions, and also that question of Indigenous co-management. And we have so many big issues in Canada already with water pollution and water availability for local communities and Indigenous communities. So I absolutely agree with those comments. And finally, I think to avoid repeating the carbon slow regulatory response, and again, even though our technology and data has advanced, we need very much that proactive measurement frameworks. And we can learn lessons from Capitals Coalition, from CSR, from all of the frameworks that are out there. We're not going to be able to do it all, but let's get the best practices online and also ensure we're doing cost benefit models that are tied to those regional water realities, and that we do follow localized governance where it is possible and encourage more adaptive and equitable stewardship. So that's all I wanted to say, and I'm very grateful to join you today.
Thank you so much for having joined us. And before asking the panelists about which of the questions you would like to address, just to respond to the question about the engagement of local governments, I think we very much welcome the different perspectives into the standardization working group. First of all, and another point is, I know that we have online a participation of ICLE, which is an association of local governments. So I think also involving such partners who are multipliers and also aggregate on the other side the local messages is good to know. So I will turn now to the panelists. Would you like to answer one of more of the questions posed? Or would you like a refresher on the question?
Great, yeah.
Yes. Sorry.
Unless Charlie, you want to take it, or do you want to refresh?
We can.
I just want to offer some general responses to the questions. Yeah, I think I want to echo the previous point that we need a cost-benefit analysis. So when we make a localized, informed decisions, we look at the, we can look at the benefit side. Of course, a data center is going to be benefiting local communities in terms of the tax revenues and also the services provided to the whole world. On the other hand, I think this environmental burden, including the water consumption, the grid, the stress on the grid, need to be quantified in a scientific way, because I guess if you just try to minimize everything, that may not be the most effective solution, since we need to have the infrastructure to support the new growth. So to have this informed decision, we do need to have this cost-benefit analysis to quantify the cost of water, to quantify the cost of air pollution to the local communities. But there are also challenges to quantify the water in terms of the dollar cost, because water is cheap, but we need to look at the stress added to the water infrastructure, added to the local water bodies. So I think having this data and scientific methodology to quantify the cost will be really important to drive the dialogue from the local community level.
Thank you, Charlie. And Sarah, if we could have a short summary of.
Yes. What can investor do? How can we attract investors to do sustainable AI for water? That's the first question. Second one was, what can civil society do to play into the decision making about establishing a data center close to a community or not? And then the last question was, what is the ethical responsibilities of tech companies and consumers in ensuring the AI development does not exacerbate global water scarcity?
Any thoughts? Yes, Colin. And then I see.
I think it's hard to see my little hand next to my thing. I think Colin was asking if I could go first.
Yeah, I was going to say ladies first, please.
You keep saying that, and I do appreciate it. And this time I'll take you off by it. But I just want to speak a bit about local civic action, because clearly that's an area that's near and dear to my heart. So my organization, we created we call it the Taps Run Dry initiative, and the idea is trying to bring citizen scientists, environmental folks, tech folks together to start trying to get this local level data, right? Like, do we know the state of our own aquifer based on the types of information that's available publicly available at the state level, at the city level, and information that's publicly available from the companies and the data center operators? Can we get a good idea of what the impact is? So trying to answer some of these fundamental questions. So that's the technical part of it. The other part is just general getting this on the radar of local and municipal leaders. Like, I spoke at my local water district for a minute and a half last week. I've reached out to my county supervisor. I think the question about, what can people do? It's what people have always done, right? Like, you show up in local participatory politics. You make noise, you bring attention to things that are of concern to you. You work with people who can help you get laws drafted, and you try to get them passed if you have some sort of local, I can't remember what we call it, but when you have people sign that they're in favor of a law so it can get on a ballot and get passed. If you have any of those kind of processes, you use those. If you don't, then you put pressure on your local leaders. But I think civic participation, there are people who do this. Like, I have connected specifically with social activists and people who work in that area, because it's not my natural area. So I rely on their expertise. And so my goal has been to inform them and put them in rooms with people who have this knowledge, either from the tech side or from the environmental side, so that they can do what they do better, right? In this particular water specific area. So I think there's spaces within each of your countries and each of your local domains where there is civic participation. I think it's just getting it on the radar of the right people, and then working the processes that you guys have had and that have worked over time.
Thank you, Mashika. Colin, and then we'll pass to the last comment.
Yeah, thanks so much. So on the question around institutional investors, I wanted to say that there is an initiative called the Valuing Water Finance Initiative, which is not focused just on any particular sector, but it has 105 institutional investors that have signed up to it, who manage $17 trillion in assets. And that's an initiative to get institutional investors to commit to pressuring the companies that they invest in to be water positive. And that's a really good initiative. I put the link in the chat here. I would encourage not just institutional investors to sign up for this, and there is an ongoing effort to do so, but also, once they have signed up, to stay firm in their conviction, because water it should be the least political aspect you could possibly imagine. Right now, unfortunately, there are changing political times, and there's a pushback in general on environmental regulations. And I think we need to stay firm on the fact that this is really important and shouldn't be about any political party or color or government in office. So that's a first thought. On the question around sort of how to capture the local priorities, I have to say that we at the Global Water Partnership, we are a global network. We work with governments around the world. We have offices in over 100 countries. And we actually work with companies that are looking to offset their water consumption. One very good example is actually Microsoft, which we've worked with in a couple of sites to match Microsoft's interest with the local government's needs. And we are, in some ways, this matchmaker, this commitment holder on both sides. So while this is, of course, a bit of an advert for GWP, the Global Water Partnership, and apologies for that, but like the Global Water Partnership, there are other organizations that operate in many localities around the world and that can really be great partners for corporates that really want to contribute in the right way. But if they do it directly without the local partners, there's often a misperception that this is about privatization or this is about the corporate interest. And from the companies I've spoken with, this is not the case. This is really trying to do the right thing. So yeah, to do that, you need help. Thank you.
Thank you, Colin. Anna?
Thank you, Irene. I want to circle back to something you mentioned about edge computing, which we didn't cover very much in the previous panel. So I wanted just to make a comment. I think edge computing, if you just look in isolation, water, it could be an interesting idea to push. But as Charles very aptly mentioned, that we need to look at things holistically. And from the point of view of energy, I think we need to be very careful because you're not creating efficiency, you're just pushing the consumption elsewhere and to a place where it's a bit harder to measure. But that's not the only thing that I think needs to be part of the conversation on edge computing, but the fact that pushing the computing load to the end user will also create a demand for people to change their computers more often. We'll force again a demand for more computers, and then we go back again to the being holistic and talk about the cost, the environmental cost of manufacturing in the ICT sector. So sorry, I didn't want to make things very complicated, especially at the end of the discussion, but I just want to go back to the holistic approaches that Charles mentioned in the beginning. Thank you.
Thank you, Hannah. And let me thank our panelists for their excellent contributions and turn it over to Clara for the closing.
Yes, thank you, Irene, and thank you also to all our speakers and moderators, also everyone who is still online and in person here. I would I think that we had fantastic input that we can use also for our working group. Please, as you can see, this is so multifaceted, so many expertise that we need. Please join the working group so that we actually do something, a deliverable that can be used. And I would also like to thank Sarah and Karine, the OECD, for hosting us. I hope that together we can achieve something more on transparency and clarity and pushing the metrics here. And I think that Sarah wanted to tell us some administrative things. Thank you, everyone.
Thank you, Clara. And I also want to thank Christy, Shelley, and Tana, who have been kind of in the background dealing with the logistics. They're wonderful women who have made this this event happen. So the one thing I wanted to say is for those of you who are still in the room tonight, we have a reservation at Radio Eat. It's at Maison La Radio. So if you want to join us, we can continue this discussion around dinner. So for those of you who are online, well, we wish you the best with your evening, and we're gonna think of you. And hopefully we can see you at some point in Paris if you're traveling here. But thank you so much, everyone, for joining, and looking forward to continuing this discussion.